Okay, let's get started. Hi guys, welcome to Zero to Hero Security class. This is Pat speaking, and can you guys hear me well? Can you give me some feedback in the chat? So I'm not sure about recently there were some issues with WebEx and my headphones. Okay, thanks. Thanks for the confirmation. Yeah, great. So let's get started. Uh, First off, let me share my screen, my web browser, and go to our schedule. There was a question in the chat before we started the class today about what's going on in the next week with the next week's class. I updated the schedule, I don't know, week or 2 weeks ago, something like that. Um, and as you can see, we're gonna have that class. There was a plan initially to not have class on, I think it was 6th of or 30. Yeah, the last day of May. Yeah, that was the date. Because initially, because that week there gonna be a Cisco Live, and when it's Cisco Live, I'm traveling to US to have some sessions, and usually I have some session on Sunday or Monday, so that's why. But this year is special. We have no Cisco Live, right? We have a Cisco Live online this year, so there is no travel needed for me. So we have that class normally next week. Okay. So as you can see, today is the 23rd. So we're gonna start talking about ISE because that's the one of the most important topics, and it's quite big as well. Like comparing to the VPNs or firepower, it's one of the biggest topics in the whole security of Cisco. ISE is a big product, can do a lot of things. Really nice solutions, and you can build really nice solution with use of ISE. That's why I would like to spend 4 weeks talking about different ISE features and how you can use ISE in your environment. So I know that we have one topic left from the VPN remote access. This is the AnyConnect connecting to the iOS and FTD. So instead of doing that today, I would like to start with ISE and have the whole 4 weeks of ISE full, content of ISE. I would not like to prefer not to start ISE in the middle of the meeting uh, because I need you guys to be fresh and ready for that those things. There are a lot of theory in the beginning, and you need to understand what's going on here really well. So I prefer to do make a decision really to move the VPN part, the rest of the VPN that we need to cover somewhere after the ISE. Probably we're gonna have some time, maybe on week 15 or even 16. So I would prefer to do that then. I did that in the past already, so it worked fine. I never, skip anything. I just moving sometimes the topics. So today let's spend on ISE, in the following 3 weeks we're gonna spend on ISE. So we should be good finishing the whole class on 27th of June, right before uh, right before the vacation, right time. Okay, so let me share my whiteboard. So today is week 11, if I remember correctly. Yeah, that's the 11. We're gonna be talking about Cisco ISE. The plan is to cover things like .1x, architecture of ISE, um, MAC authentication bypass, different host modes, also go to any connect now. So basically today we're gonna be talking about authentication, network authentication in the wired environment. um, Next week gonna be wireless, I'm sorry, wireless environment, and so the guest access plus the posture in probably the VPN. We'll see. I think this is the most popular, so I will cover that. Um, any wireless prerequisites for ISE wireless access? Not really. Um, Even the wireless itself is, it's out of scope for security. We will just be touching the wireless LAN controller in case of configuring some basic settings for SSIDs. So we're gonna be just creating some new SSID with some special configuration for radius in order to make this whole thing work. Plus some security features like MAC filtering, access lists on the wireless LAN controllers. So no strict wireless technologies at all. Right? So that's not. Nobody wants you to know how to build the scalable wireless full mesh network. That's not the case. You see posturing being enabled for Linux in the future. Looks like posturing is not supported. Yeah. Yeah, it's only supported on Mac and Windows at the moment. I think it's gonna be, but probably there is not that big demand still for such thing. But I don't have any exact date for that because that's out of my reach, really. Yeah, but let's start with that. I know that some of you may already know how ICE works, but I need to start from the very beginning. So let's move on and first talk about something called ICE personas and features. Because if you want to deploy ICE for network authentication and authorization, you need to create an ICE server or install ICE server or deploy it in your network, and you need to run some features on it. And depending on how many servers you have and how scalable your solution should be, you can have one server or more servers and multiple features enabled on those servers. So you need to know what we can really enable or disable on a per server basis. So we start talking about something called ICE personas and features. Okay, so basically each node of ICE setup, node or server, that's basically the same. We call it node because it's like kind of like a cluster of multiple servers. can be one of these, can have a role. Let's say persona, that's a strange word. Persona is like a role, okay? Or basically major role of the server or node. Node equals server. Okay, so each server or node can have a role, main role. One of the role, basically we have 3 or 4 roles really. PAN, that's the first one. It's a policy admin node. And that's basically the management node and GUI. Okay, so you need to have at least one of these in your deployment to make that work, because you must have some way of configuring ISE. There is no way to configure ISE from the CLI except things like IP addresses, routing, stuff like that. But in case of policies, different policies, authentication, authorization, uh, integration with some other servers, only the GUI is way to go. Another role or persona is the MNT, monitoring and troubleshooting. Okay, basically you can think about this like a log collector, right? So all logs will be on this server. It might be the same server, like the PAN and MNT, both roles can be on the one server, or multiple servers. We'll see that in a moment, because depending on your deployment, when you first decide how to deploy your ISE, then you need to decide which server will have what person or role on it. And the third one is the most important, actually, called PSN, Policy Service Node. Okay, this is where you have your individual services running, like Radius or TACAX or Profiler. Okay, those services will be running on the PSN. So this is your work horse. You can think about it like this. Okay, and you obviously may have multiple PSNs. So those 3 are personas. Now, PSN may have some additional features enabled depending on what service you're trying to enable on it, or enabling on it. One of the most important is the session service. And basically the session service is the Radius server. Okay. Another one that you can enable is device admin service. And this is another way of saying TACAX. So if you're trying to enable AAA services for device administration, to authenticate and authorize your administrators that are connecting to a device, trying to manage it, then you use TACAX for it, and the device admin is the service that must be run. The next one is Profiler. So Profiler is a service that allows you to profile a device that is connected to the network. Basically, adding this device to a group of similar devices. So if you have a printer connected to a network, that printer will be profiled as a printer and added to a group of printers. Right? If that's the workstations with Windows 10 connected to the network, then it's gonna be grouped together with other Windows 10 devices. Right? If you have some other devices connected to the network, then they're gonna be profiled as well. So profiler is the way to find out what is that device connected to the network, what is the endpoint connected to the network, or to the switch, or through the wireless controller, whatever. I'm gonna be talking about this a lot of more later. The next service that you can run is called a TC NAC. This is relatively new thing. Um, it's a threat-centric network admission control. Threat-centric NAC, network admission control, is about integrating ISE with some threat or anti-threat, really, solutions, and you can grab some additional information out of those systems and import to ISE and make some better decisions on ISE, including in the making the decision process that additional threat related information. For example, you can integrate with a Qualys or with a Rapid7 or with Cisco AMP. Okay? If you integrate with such products, you can get some additional information about what's going on this specific endpoint from the threat's perspective. If there is a threat, you can make some additional or make a decision about this endpoint. You can quarantine that endpoint. You can disconnect it from the network. You can shut down the port on a switch when the endpoint is connected to, things like that. I'm going to be talking about this later. Another one is the SXP service. SXP is the SGT or Security Group Tag Exchange Protocol. SGT, abbreviation in abbreviation. SGT Exchange Protocol. Okay, we're gonna be talking about the TrustSec stuff. So SXP is part of the TrustSec, is the ability to manage IP to SGT mappings. Okay, so if you have a host connected to the network, you know the IP address is this of that host, and what is the SGT security group tag associated with that host or group of hosts, and that mapping might be delivered somewhere in the network, sent to some devices. Would you run a dedicated SXP node? Actually, yes. You need to just run PSN and just check SXP on it. I'm not sure if you possibly can, uncheck the session service for that. I think that's still possible. So just I'm not sure. We can check that, but I'm pretty sure that we can uncheck everything except SXP. Yeah, we're gonna be talking about that. So yeah, we'll see. Another one is the passive ID. Again, some relatively new feature that allows you to enable network authentication authorization without enabling .1x or without using .1x. Okay, so that's pretty cool because a lot of people don't want to deal with .1x. basically the problem with a .1x is not the protocol itself. The problem is on the endpoint, the multiple supplicants software that can change its behavior because of I don't know, some fixes or new patches, new service packs on the endpoint that can change the behavior of the so-called supplicant .1x supplicant. So it's just a piece of software that talks .1x. So that's basically makes the thing or things worse. And a lot of people don't want to deal with .1x because they afraid of all those possible issues and problems. So for them, there is a passive ID. You can authenticate to, for example, to the Windows domain, and then ICE will grab some information from the domain about that authentication, will create a session, and will just authorize this endpoint to the network based on the authentication session that was actually taken from the domain. So ICE is not really authenticating here. ICE is authorizing. We'll talk about this later again. And finally, so those things are features that you can enable on a PSN. And one more persona is the PX grid. So PX grid, you can think about it like integration service, kind of API integration service with other systems. Why other systems should integrate with ICE? Because maybe they can use ICE as a source of information about session for a user or endpoint. So can grab that information about that session, can use ICE to tell, to quarantine some endpoint, saying, please quarantine this session because of something happened on my side. So that's the integration. We're going to talk about this a little bit later as well. Integration service or API. Yes, so the whole .1x posture, guest, everything like that, yeah, comes under the session service. Right. So now we know what we can enable as a role or feature. Now we need to talk about how many servers do we really need in our deployment. And we have kind of three of possible ways of doing this. So ICE deployment modes. The first mode, I call it standalone or primary secondary. Secondary. This is the deployment when we run all personas and features that we need on one or two nodes or two servers. Okay. Runs all personas, features on one or two servers or nodes. Okay, there's a question in the chat. Okay, you tried to run .1x but had some problems in the wire. You roll back. Okay, you're asking about this passive ID. Is it something that people use? I think so. If I would say, try to guess how many people use passive ID versus .1x. It's like 80% .1x, 20 passive ID, or even less. So it's not that popular. Yes, is it? Yeah, yeah. .1x works. Yeah, yeah. I did in my career. I did some deployments. The biggest deployment for .1x I did with a customer. It was for 40,000 endpoints. It was quite large, and we had multiple problems with .1x because of different devices and endpoints connected to the network. So yeah, the common issue is it's not the technical issue. It's actually the process that people try to use, because most people, when they are trying to deploy ISE, they think that ISE can be deployed in maybe 1 week or 2 weeks, which is not possible. From my experience, I can say it's from months to years even, because this deployment, I said 40,000 endpoints. We did that deployment in 18 months. It took 18 months to finish that deployment, and that was because of multiple different devices, like old switches, newer switches, latest switches, different software versions, different supplicants, three type of endpoints: Windows, Linux, and Mac. Uh, Multiple authentications, or different authentication types, and so on. So it had to take a while. There's a question: do you usually see customers use the NAM or native supplicant? Okay, so I think most people use native supplicant, but again, this biggest deployment I did, that was with a use of NAM. Simple because NAM can do heap chaining, something that is not possible to achieve on a standard native supplicant. We're going to be talking about this, and this is a real thing. I think it's a very important concept to understand. I'm going to be talking about this later today. Okay, back to our deployment mode. So one or two nodes. Obviously, one node, that's not a deployment. Okay, not in the wild. At least two nodes are needed. So one deployment can be in the lab only. So you have, let's say you have two servers. That can be obviously the virtual servers running on the ESX, for example, or some appliances. So you can buy appliance with ISE software on it. So this is node 1, and this is node 2, and you run policy admin node, MNT, the monitoring troubleshooting, and the PSN on node 1, and you run the same on node 2, and you make them to be primary on one node, secondary on another node. Okay? You can even say, okay, MNT gonna be secondary on this node and primary on this node because of the load. Okay, PSNs, there is no concept of primary, secondary. PSN is always primary. Okay, so there is no concept of active standby or something like that. They always running, but obviously you can decide what to put, what features enable on them. So for example, one PSN can have a radius running, one can have a TACAX running, or both will run radius and TACAX. Obviously, it's important from the AAA services perspective to have a high availability. So if you have a network device like a switch, right, this switch talks to this server PSN with radius, and for example with this PSN with TACAX. But it is configured this way. Even if this node 1 dies, the radius session can be handled by the node 2. Okay? So this device, like this switch, we call it NAD, network attached device, or network access device, some people say. I think it's even better to understand the role of it, right? We are accessing the network to that device. Or we call it just the AAA client from the ISE or AAA server perspective. Okay? So this device can be basically switch or ASA, like a firewall, or WLC, because there are basically three ways to access the network: either wired, wireless, or VPN. Right? There is no other way to access the network. So that's why we have only three of such devices. And our endpoints are connected to that switch, right? Those are the endpoints. Endpoints can be a host, can be a printer, can be some medical device. Obviously, can be also a user on this host. We can have a double authentication, like host authentication plus user authentication. Okay, so when we actually think about this deployment mode, all depends on the size, because this deployment mode supports up to 20,000 active sessions. Okay, so if you run ISE on the most high-end ISE nodes or servers, or if you put it on a VMware and you add enough resources to that node, then you can support up to 20,000 active sessions. Okay, what is the active session? Active session is when this endpoint is authenticated and it's actively using the network. So there is a session on the ISE server for that endpoint. Okay. If there is a session for this user also, there's gonna be another session. Okay. So it's completely different than the number of endpoints that we can have in our network. Okay, because ISE is supporting currently 1.5 million of endpoints. Right? But not all endpoints are active at the same time. Yeah, so it's one session per device. Yes. Let me put that endpoint. So endpoint is basically a host or printer, tablet, right, or IP phone. Right? So if you have one user, right, you cannot say I have 5,000 users in my network. That means I have 5,000 endpoints. No, we usually think about this way. One user might have up to 3 endpoints. Right? For example, a user has laptop or tablet, laptop or just standalone host workstation, and maybe IP phone, right, on a desk. So three different endpoints, even for one user. Wireless access points can be, if you decide to authenticate them, yes, then yes. So you need to think about this way. If you have 5,000 users, you may possibly have 15,000 active sessions or endpoints and active sessions as well. Okay, so you never scale up to the full capacity, obviously. So you need to have maybe, even if it's in theory supporting 20,000, this network with 5,000 users, that is something that is, I think, fit in, but it takes everything. Okay? No resources left. Okay, but those nodes doesn't need to be on the same network. I mean, you can put one node in one data center in one city, and you can put node 2 in another data center in a different city. Okay, because they need to be visible to each other, but over layer 3 network. Okay, so that's good from the high availability perspective, because you can put those nodes in two different data centers. But you need to think about this, where you have users connecting to the network, when you have nodes. Okay, and it's maybe better to not have the users. Let's say you have 5,000 users in New York, and the node is in Los Angeles. So that's not a good deployment, right? Yeah, that's a good question. So the question in the chat: what will happen if a company first use the standalone or primary secondary? That's going to be the case, and then they need to increase the deployment because of more users, more devices, and so on. That's why I think this is not the best way to start with. It's better to start with another deployment mode, which I call small distributed deployment. With a small distributed deployment, you must have at least 4 servers. Okay? Can be virtual, obviously. So you say this way. Okay. You run the GUI and MNT on the one server, the GUI and MNT on another server. That can be primary, secondary, primary. and then PSNs on a separate servers. PSNs are the workhorses, right? So we need to scale them. So for example, you can now put them in a different locations. For example, the DC1, they're gonna be the primary device. Data center 2, they're gonna be another device, and the PSN, you can put them in branches. Branch 1, branch N. Okay, and you may have up to 5 PSNs like this. And the devices like network access devices like a switch or ASA or WLC, the LAN controller, talk to those PSNs. So in this case, you can increase the load by increasing the number of PSNs up to 5. But to start, you must have at least 4 devices because of you need to have PSNs on a separate servers. Question in chat. Let's say you have 2 PSNs in branch 1 and 2 in branch 2. Okay. Would you place them in groups even though you have no load balancer? No, I would tell you how I would do that in a moment. Okay, we're gonna be talking about different ways of putting or configuring AAA services on those devices or NADs. So in case of sizing, might be surprised, but it supports up to 20,000 again active sessions. If you use some older servers, or it may also support up to 40,000 active sessions with the latest hardware. So there are some new servers that allows you to support up to 40,000 active sessions with this deployment. And the benefits of that are scalability, because you can easily scale by just adding the PSNs to the deployment. Locations, because you can put those PSNs in a different locations. And it's basically a little bit faster because of not sharing different functions on the same server. Okay. So even if you have, if you think about what is the most loaded role or loaded persona, is the MNT. MNT is the killer. Because it's constantly logging information about sessions, okay, and some multiple additional things are being logged as well. So MNTs are really killing the disk and killing the CPU. So if you have PSN on the same server here, that PSN and the radius services that this PSN is offering may be affected because of that shared resources on from the same server. That's why if you have that this way deployed, it's gonna be much better, and you are being safe on the safe side. Okay, you shouldn't be afraid that something can kill your PSN because of a load. why that's my favorite. Even for if someone today has, 5,000 users, I would really go for this because that's the future proof, and it's much better. You will not have, issues with performance. Plus, the decision can be made based on this locations, because if you have multiple locations, maybe better to put PSNs closer to your network access devices. And finally, there is a big distributed deployment. Oh, so Reminder is asking, so isn't it a better choice to move MNT to branches? Like, I do not want my logs to traverse MPLS expensive circuit and use bandwidth with, will it be a good design? Um, you actually should put it where you have the most of endpoints. That's my opinion. Then it's not traversing the MPLS, right? Or any expensive, circuits, like I said. Okay, and the big distributed is when you have everything separated. So you have one node with just a primary PAN. Then you have separate node for MNT. You have another node for PAN, for secondary PAN, and another node for secondary MNT. Okay, and then you have PSNs, again on the separate servers. And this time you may have up to 50 of PSNs. Okay. Also, you can mix hardware and software-based, servers. So, for example, you say primary and secondary, or sorry, primary PAN and primary MNT gonna be on the hardware appliances, and the secondary and secondary MNT gonna be on the ESX. Right? Might be like this. This is gonna be working fine. Sizing here is up to 500,000 active sessions. Pretty huge, right? And you can deploy your PSNs in multiple locations. So so far, the biggest deployment in the world of ISE I know of is for more than 200,000 active sessions. Right, so that's a big one. Yeah, so yeah, snapshots, things like that. Yeah, obviously that might be a problem with that. To be honest, I prefer ESX or for ISE deployment. You know why? Because I don't need to update or upgrade my hardware, every couple of months. Because when Cisco is presenting new servers to be used for ISE, the other servers, the old servers, will be end of sale and end of life eventually. So if there is end of life, I need to change them. So with the ESX, it's easier to maintain that. That's the one. That's the one reason. Another reason is the snapshots. At least for you know things like when I'm doing some upgrade. Okay, maybe not for like a backup solution, but upgrade. Three, if you have a good ESX deployment with vMotion and stuff like that, you can actually may have this deployment very resistant to any failures, right? The only condition is to have good resources not shared with anything dedicated to those devices with especially the disk. The disk is the bottleneck here. Okay, if you have fast disk uh, and it's dedicated, you're dedicating some IOPSes or stuff like that, then it's gonna be really, really nice working deployment. Yeah, in the lab we will run everything on the one server, obviously. Um, are the amount session per PSN? Yes. And I'm gonna show you. Um, I will find it in during the coming break. I have some presentation with some slide on it where you can find the numbers of sessions per PSN. Because I don't, remember them because it depends on the hardware that you use and so on. But it can be found in in release notes and the deployment guides. Those numbers. Okay, so now how we can point our network access devices to the PSN, right? There are multiple ways to do that. How to do HA of PSN and NAD. Obviously, the most common is to configure more than one PSN on NAD. Right? If you have PSN 1, PSN 2, and PSN 3, right? And you have some switch 1. This switch can point to PSN 1 and PSN 2. Switch 2 can point to PSN 2 and PSN 3. Because all PSNs have this exactly the same information because they are being managed by the same admin node, so they have exactly the same info. They can handle any of these PSNs can handle sessions from those devices. Okay? We basically do a AAA server group on a switch, call it ISE for example, and we put server PSN1, then server PSN2. The server obviously must be also configured in a configuration. Um, yeah, it's about the PSN replication. It might help you, but it's not. It basically the PSNs should have the same information. It's just a matter of how PSNs can communicate uh, with policy admin node. No, not needed. No. Right. So that's the obvious one. But remember that in case or from the perspective of that switch, only the first one will be used. If it's alive, it's going to be used the first one. The second one will never be used, or will be using or used when the first one dies. Only when the PSN1 is not responding at all, then the PSN2 will be used. So there is no load balancing, anything like that. But maybe you know about it, maybe not. There is a software radius load balancing on the switch. Switch radius load balancing. So you can use, with this configuration, you can load balance across those two PSNs with a round robin fashion. So if you have a switch, again, multiple PSNs, you can basically configure all of them and do round robin load balancing. There is a, if you go to Google and say Cisco switch load radius load balancing, this is the first article here, radius server load balancing. Notice that this feature is from 2006, so it's 14 years now, or a little bit less than this. It's really easy to configure. Right? When you're configuring the AAA group, you have under the group, you need to put load dash balance command. Method, list outstanding, and something like that. And you're gonna have load balancing across those servers inside that group. Really, really easy. Put that link in the chat. Okay. Number 3, if you have bigger deployment, it's good to have hardware load balancing or load balancer. Then your switch is configured with only one IP address of the PSN, which is just the VIP, the virtual IP of a load balancer. Right? You have load balancer, and behind the load balancer, there are multiple PSNs in the one location. Okay. So with a big deployment, if you have maybe 40 different PSNs across the network, maybe that's the good, better way to handle that many PSNs. You ever use auto radius probes for dead peer detection? It's a nice feature, but I don't like it because it's adding some messages to the logs. I don't like that. Okay, it's a little bit faster because this basically it's just when the server PSN1 dies, it's gonna faster tell the switch that this server is not responsible. Okay, so it's gonna be a little bit faster. You will not waiting for a timeout, basically. But other than this, it's not really that useful. Okay, 4, you may even use DNS load balancing, right? Because on the DNS, when you have multiple A records for your PSNs, right? Then you can point to a specific PSN. Right? You're asking for FQDN, your DNS. DNS gives you the IP address, and the IP address is of the PSN number 1. And when you ask again, you're gonna get another answer from PSN number 2 and so on. So you can also do this. You can, I think about this, you could even use Anycast for this, but problem might be because when the PSNs may have a different IP addresses, so not sure if that's gonna work this way. From the deployment, it must have a different IP address, so Anycast, it's not that possible this way. Okay, those are the most popular ways of configuring. From a small deployment, number 1 or number 2, from a bigger deployment, number 3 or even number 4. Okay. You know what? Let's take a quick break, because after the break we will be discussing how .1x works, and that's going to be the most important information today, I think, to better understand how it works and what we need to have on enabled on different devices in order to make that work. Okay, so let's grab a good coffee and be ready for the next topic. Okay, let me put here 15. So see you there in 15. Okay, guys, let's continue. So I found the presentation I was talking about, the case of scaling. It's not the latest presentation, so you can try to find out uh, breakout session on a Cisco Live. It was the Cisco Live 17, so it 3 years ago, 36.99. And the presentation is about scaling as well. So as you can see, maximum internal endpoints is 1.5 million on ISE 2.1 and above. Internal users is 300,000. Okay, what else is important? Let's take a look at the next one. Here we go. Maximum concurrent session counts by deployment model and platform. So see, you have here maximum session per PSN. Okay. Notice that it depends on the platform. For a larger platform, it's up to 40,000 sessions per PSN, which is huge, right? So depends. Yeah, so you need to find out the latest document like this, and you will find the. I will try. I had no time to look for newer data, but I will try to find it and let you know if there is something like that available later. Okay, let's go on. So the next thing I wanted to talk about is how .1x works. What is the .1x really? And I think this is one of the most important slides for today. So obviously the network, the .1x is a network access use case. We are trying to authenticate and authorize someone or something that is trying to get access to our network. So typically, we have a user with some endpoint connected to a switch, to a port on the switch, right? This switch is somewhere connected through the campus network to ISE. That can be somewhere in a data center or some other network segment. And also very common, where behind the ISE we have Active Directory for authentication. I'm going to be using this in our lab too. So first off, you need to understand that the whole purpose of doing the network access is to authenticate someone before he or she or it gets access to our network. So let me know, guys, what about my audio? Okay. Thanks for the info. Right. So think about this. The network access use case is to get to authenticate something or someone before he or she it gets access to the network. So this switch port is basically closed for us. We cannot send any traffic except actually .1x in this case. So we cannot even get an IP address. Right? So how we can deliver credentials to authenticate to ISE server, because that's the ISE server that will make a decision what to do. The ISE server gonna authenticate us, or even Active Directory will authenticate us, not the switch itself. Okay? So the thing is how to deliver our credentials to ISE server for authentication. Obviously here, since we have no access to the network, no previous access to the network, we cannot even send any DHCP discover message to get IP address. We have no IP address. What we can do, how we can deliver that? Remember, this is for us a layer 2 network segment. Okay? Here we have layer 3 because that's the campus, so it's routable network. But here we have a layer 2. We need to find a way to deliver the credentials from this guy or this endpoint up to ISE. Okay? That's why someone figured out a layer 2 transport protocol, okay, to deliver those credentials. This layer 2 transport protocol is called .1x or 802.1x. That's why we call it .1x. That's the standard, 802.1x. This is the layer 2 transport protocol. Okay? It must be able to send something from this host and deliver it to the switch. Obviously, this is just a transport. It's not getting or transporting our credentials in layer 2. It must use some additional protocol on top of it to carry those credentials. This protocol here is called EAP, Extensible Authentication Protocol. Okay? And depending on how you or who you're talking to, you can have some academic discussion. Is it a layer 3 or layer 7? For me, it's a layer 7 because this is the payload. Okay, so for me, EAP is a layer 7. But anyway, I don't want to start any academic discussion about is it is it layer 7 or layer 3. Credentials. So IP is there to carry our credentials. Right. So now, in order to create a layer 2 transport with 802.1x, we must have something on our endpoint that can build this packet for us. This something is called supplicant. Right? Supplicant is just a piece of software that can talk 802.1x and can use IP to grab our credentials and send it over layer 2. Then from the terminology perspective, the switch or the network device at the network edge is called authenticator. Even though this is not a good name for it because it's not authenticating us. And the ISE server, in this case, that's going to be the authentication server. AuthC, we call it for short. Okay, so we have supplicant, authenticator in the middle, and the authentication server. Right, so we have this packet delivered to the switch. Now, switch has no idea about this IP. Okay? Switch does not understand what this IP about. It cannot grab those credentials, cannot authenticate us because the switch has no user database on it. By the way, credentials can be different. That's why we have IP for, right? Because there are many different credentials out there. It can be username and password, that's the obvious one, but also certificate, passcode, one-time password, challenge response. Okay, so there are more than 40 different credentials out there that IP can support. So IP knows how to grab those credentials, how to deliver those credentials to the other end. But it's delivering it only to the switch in this case. Now, what will happen then? Then the switch must deliver those credentials to ISE. But we don't have layer 2 anymore here. On the right, between switch and ISE server, we have layer 3, because ISE can be in a different city, in a different data center. So how we can do that? Instead of using 802.1x as transport for those credentials, it's now using well-known Ethernet. On a layer 3, on top of the Ethernet, we're going to have IP. On a layer 4, we're going to have a transport protocol called UDP. And on top of that, layer 7, we're going to have radius. Okay, this is a layer 3, so we can, this is the routable packet now. The thing is that the switch is just grabbing the whole IP payload and put that IP payload into the radius in AVP 79. What is the AVP? AVP is the attribute value pair. Right, like privilege dash level equals 15. Actually, it's LVL equals 15. That's the attribute, and that's the value of that attribute. Or username equals Cisco. That's the attribute and its value. Right? This is how radius works. Radius is the packet, or it's a protocol that is delivering AVPs between some two entities. Okay, so what switch does? switch basically puts the whole IP from that packet into the AVP with a number 79. Actually, each AVP has its number. Like username is a number 1, password is number 2, right, and so on. So there is a special AVP 79 to put this IP into and send it over to ISE. So from the supplicant perspective, we have, even though we have layer 2 and layer 3 here, we're still delivering the same information, and the supplicant actually thinks that it talks directly to the authentication server. Supplicant has no idea about someone in between. Okay. In here on the left, we call it sometimes IP over LAN, IP OL, IP over LAN or .1x. Right? Here we have a radius as a transport for our credentials. Now, looks fine, but the problem is that even IP was invented to understand different credentials and to carry those credentials to the other way. The problem is that IP is not meant to encrypt or secure those credentials in any way. Okay, so IP is not providing security to those credentials. If you have username and password, you put that into IP. If someone sees that packet, he or she will know what is a username and password. It's a clear text. If it was clear text, it will be clear text on the wire. Yes. But that's not the end of the story. That's why we need to first build kind of tunnel, secure encrypted tunnel between our supplicant and AAA server, or ISE in our case, okay, to provide that security. That's why you may found and you may think, oh, okay, what's going on with those IPS methods? Why do we have those methods? What is that method really? We have two kind of IP methods. We have an outer IP method to protect, to build this security or secure tunnel. And we have inner IP method to send the credentials over this secure channel. The most common outer IP method is called PEAP, P-A-P-E-A-P, protected IP. Okay. How does it work? It works like SSL tunnel. Remember from the previous week, when we are connecting to over HTTPS to a server, right? In this case, this is going to be supplicant, and this is going to be ISE server. Over the PEAP, there's going to be certificate sent from the server back to the supplicant. This certificate must be authenticated, right? So there is a signature in that certificate, so we need to trust that certificate. By default, we are not trusting this certificate if this certificate is self-signed. But no, basically the same thing like with SSL for HTTPS, okay? But in this case, we are validating the certificate and build kind of SSL tunnel between supplicant and ISE server. So PEEP gonna be the outer method. Okay, what is the common inner method though? It is called eep-mschap v2. Why is this very common? Because this is the Microsoft way of authentication. Microsoft is using CHAP authentication, which is the challenge response type of authentication. So inside this, we're gonna be eep mschap v2, okay? Or maybe eep md5 if we use md5 as an authentication, which is quite old. Usually some old IP phones is using it. Or we can use a certificate authentication, so eep TLS, right? Transport layer security. So then we are providing inside the secure tunnel, we are providing our certificate for authentication. By the way, that might be confusing because eep TLS can also be the outer method. Okay, because it can still build SSL tunnel between supplicant and ISE server, but in this case we're gonna have mutual certificate authentication, right? So tunnel will be authenticated mutually with a certificate on supplicant side and ISE side. Okay, and another quite common is called eep fast. Okay. Fast is the Cisco proprietary outer method, and it's using, instead of certificates, it's using PACs, protected access credentials. The eep fast was invented by Cisco 20 years ago or something, and it was the answer to questions from customers that didn't want to use TLS because they didn't want to use certificates to create a PKI, the public key infrastructure, maintain that, deliver certificates to the clients, and all that burden that you need to have with certificates. They wanted to have some simpler solution, but very similar to the certificate authentication, so mutual authentication. So the PAC, it works like RSA, authentication using private public keys, something like that. But it does not require certificates. We can deliver that PAC to the client without any authentication. It can be online delivery, automatic way of delivering this PAC, those credentials to build that tunnel. So what is the most common though? The most common we need to always think about like tandems, right? Outer plus inner method. For Windows, the PEEP is the outer. This is the most common. PEEP is the outer, and eep mschap v2, right? Because that's the Windows type of authentication. For Linuxes, since Linux has no eep mschap, it's usually using either PEEP as the outer and eep TLS inner, so certificate authentication, or something called eep TTLS, which is basically using TLS as the outer and TLS as the inner. things like printers, right? So some unmanaged devices. You can have either IP MD5 or basically MAB, which is the MAC authentication bypass. So you don't have any supplicant and you need to authenticate this printer somehow. So you are using printer's MAC address for authentication. I know mobile devices, usually certificates as well. So IP TTLS or TLS with PIP eventually. Okay. So now you should understand that we always have two IPs. One IP is the outer, one IP is the inner. One IP is responsible to build that secure communication channel, or another IP is for delivering credentials to the other end. Right, and obviously I have some Wireshark captures of that. Let me find out real quick. IP phones. For IP phones, it depends on the model of IP phone, because the newer models can use TLS because they can have certificates. So when you have those IP phones connected to the or managed by the call manager, the call manager can be a CA basically, and can deliver certificates to IP phones, and then you can use those certificates. So IP TLS gonna be the common authentication. Or a lot of people don't want to do that because they don't know how certificates work. Then they just don't enable that and they use MAB, MAC authentication bypass for IP phones still. Okay, here we go. See this Wireshark capture? This is the Wireshark capture between supplicant and the switch. So on this layer 2 link, this is the capture on the client side. Notice that the name of the capture is the IP over LAN.1x PIP client side, right? So notice that the first packet, notice this is the layer 2. Layer 2, we have Ethernet, right, destination, and we have 802.1x authentication. IP packet, this is the type of the next, the payload, and we have IP here, extensible authentication protocol. And the first packet from the client, actually that wasn't from the client, that was from Cisco. Notice the source is the Cisco MAC address, which is the switch. So switch sent IP request identity. So it's like a probing. And the supplicant on the client should respond here. So the next one, notice the source is VMware, which is basically from the client to the switch, is the response identity. And notice that identity is Piotr, and this is IP. And then we have request. Notice the protected IP. So now we are not requesting just the password. We are now want to protect that. So the switch is requesting protected IP. Actually, it's not the switch that was protecting this IP. Requesting this protected IP. That was the ISE server. Let me put that real quick on the slide. So what we have here is this. Switch, ISE. So the first, actually, this one, we had a request identity request ID, right? That was the IP packet. We got the response ID. Now the switch put that into the radius, right? So underneath there was a radius. Here underneath 802.1x, right? And inside that radius, it started the session on ISE. Okay, put that information into the radius AVP 79. I said, okay, someone wants to authenticate with me. Let's send him a radius message saying, okay, in the AVP 79 or 80, by the way, as a response, there's gonna be information. You know what? We need to use PEEP actually for protection. Notice this here, EEP-PEEP. So this is the request from ISE, not from the switch itself. Switch has no idea about PEEP, different EEP methods. No idea about that. Right? That's why switch sent that, put this information back into the 802.1x packet and sent the request for PEEP. Okay. Now, since that's the request for PEEP and PEEP works like SSL, right? The next one is, notice the client hello. It's just a SSL or TLS, right? Actually. So we have SSL, secure socket layer. See this in the packet? That's the client hello. We are going to negotiate a tunnel, like with regular, right? We are presenting our ciphers that we can use to protect that tunnel. Okay, and they're gonna be server hello, and notice in the server hello we have certificate. So we need to understand and we need to verify that certificate. This is the certificate. So we, on the client side now, we need to verify the certificate, verify the signature. Notice, remember, to verify the signature of that certificate, we need to have certificates of CA that signed that certificate, right? So that's very important thing. Once we do that, then we have client key exchange and a change cipher, because we want to start encrypting data. Right? Some 4 packets, and we negotiated the SSL. And then another IP message. Okay, response for the IP PEEP that we done that, and we can now send protected data. Notice the next packet is just the TLS. It's still IP request, okay, from the Cisco, but now it's protected with SSL, and we have encrypted data. So we don't see that anymore, what's going on. So we don't see the identity, we will not see the password and any other things that are being exchanged. What did you enable in order to get your VMware Windows machine to support .1x? You'll see. You'll see. I will show you that in the lab today. Yes, it's gonna be difficult if you do that this way as you described. Okay. How does it work, or how does it look from the other perspective between the switch and ISE server? Let's take a look. I have that conversation as well. Here, EPO.1x PEEP server side. See, that's the server side. We have radius. See? Between the switch and and the ISE server. So we have a radius, obviously layer 2, layer 3, layer 4 is UDP, and the radius is layer 7. See, this is the first one is the access request. So actually here, this packet here, that was the access request message, type of message, radius message. Okay. Inside this message, we have AVPs. Notice the username is Piotr because that username was in the first packet, right? Plus some other information about this this endpoint. So where this endpoint is connected to, what is the MAC address of that endpoint, and notice the IP message number 79. Okay, so that's the IP message that we had in the first packet, in the protected IP actually. Okay. Then IP challenge, access challenge is the kind of middle packet if we need to negotiate something. Okay, so this access challenge, request, access challenge, those 4 packets are basically about negotiating this SSL. Because the whole negotiation, remember, supplicant thinks that it talks directly to ISE. Right? So this SSL is negotiated between supplicant and the ISE server. Right? Basically, the transport method is just different, but the payload is exactly the same. Right? And finally, we have access request, and we have access accept. So this, after the setting up the tunnel, we have access request, but protected by IP, and access accept to provide information that the authentication passed successfully. Okay? So that means for the switch that, okay, we can open that port. Plus, access accept may have some AVPs for authorization. Like we can, for example, specify the access list or downloadable access list to be put on that port. And we can, this DACL can be applied to that port to open that port, but with a limited access to the resources. Good question. I never saw any document, any information about attack, using this. No, I'm not aware about that. Okay. The TLS runs inside the AVP 79. Okay, this is the payload, and this payload is basically just having 2 different delivery method. One on the left side is layer 2 802.1x, on the right side is the radius AVP 79, and that's it. Switch is not touching those messages. So the whole SSL is basically here in this AVP 79, delivered to ISE. I puts that and or gets this AVP, checks, and and build a response to the switch. Switch will again send it to the supplicant. Right? because the radius is just a protocol, a mechanism to deliver AVPs between two entities. AVPs only. Some information in the AVP format. And one of those AVPs is the IP message that I'm showing you now. And inside this IP message, we have that SSL negotiation here. Not here, but the SSL negotiation is, for example, here in access challenge. See, the type is protected IP, and we have SSL, TLS inside the AVP 79. Okay, I hope this is, guys, understandable. Let's move on. So I started talking a little bit about the authorization, right? Let's extend on that. So, okay, I can save that. Auth Z this time. This is the authorization. Authorization. Okay, I hope it's now clearer, Ronaldo. So basically, we have 3 access methods to the network, right? We can either use wired, wireless, or VPN. No other way to access the network. Right? So in a wired, when we authenticate this guy here, or this endpoint, the switch port, right? Then there is ISE somewhere in the network, and obviously here we use 802.1x or .1x to deliver traffic or to deliver credentials, radius on this side. Right, so radius access request first, and then as a response, there's gonna be access accept message. Access accept message, radius message, tells the switch that the authentication passed. And access accept is the only message that can deliver authorization attributes. Okay. Radius access accept message can deliver authorization attributes. Right? Authorization is the way to tell this switch how or what on the network this endpoint can talk to, or what can be done, or what can do. Right? Because authentication is telling what you are, right? Authorization is what you can do, right? It's about. So the most common is gonna be either DACL, port ACL, the name, or VLAN, right? Or SGT, security group tag. We're gonna be talking about this later. So once you get this switch port will be open with the ingress ACL, right, set to port ACL that we got from the radius. obviously this is the layer 3 access list. Okay? It doesn't really matter that this switch is the layer 2 device. The port access list can be layer 3, so it can filter the traffic up to the layer 4, actually, including ports. Okay? So that's the method, the most common method of authorization, by applying the access list to a switch port after successful authentication of the client or the endpoint. Okay, wireless, it's a little bit different. Right, we still have that user with some workstation, but then we have some access point. Right? This access point is having kind of tunnel again with a WLC with the controller. We call it this tunnel CapWAP. It's actually layer 2 tunnel. And WLC talks to ISE. Right? What is the most common authorization here in the access accept message? Again, access list, but this is the ACL name, not the DACL. DACL is the downloadable access list, which is the access list that can be configured on ISE server and can be delivered on demand to this switch. So you don't need to have to configure that access list on multiple switches. It's going to be downloaded automatically from ISE. In WLC, in the wireless environment, there is no way to download an access list. You must just provide the access list name. There is a special access list in the WLC called airspace access list. Airspace ACL. So you just need to put the name of this access list, and this access list will be applied here, but this is the access list that is configured locally on the WLC. Again, here you have 802.1x, and the transport mechanism is actually, or not Ethernet by 802.11, which is just equivalent to Ethernet in the wireless network. In a VPN world, it's a little bit different. You don't have .1x because you're not layer 2 connected. You're building a tunnel between on layer 3, right? Let's say the ASA is the head end. ISE is somewhere in the network. And again, this is the now AnyConnect. This is the layer 3, not layer 2 anymore. So AnyConnect is just authenticating during the connection setup. Authentication is over radius against ISE or maybe even Active Directory. And in the access accept message, the radius is delivering ACL name again. That's gonna be applied here to the tunnel of this user as a VPN filter. Remember last week we talked about the method, how we can limit the traffic that is going into the tunnel. VPN filter is one of those options. It's just an access list applied to the user's tunnel. Okay. That's obviously this again ACL must be applied as a VPN filter, must be configured here locally on the ASA, cannot be downloaded from ISE. Same with WLC. It must be on the controller. It cannot be downloaded from ISE. The only way to download, to use DACL, is the switch. Okay. Next thing. So the most common, once again, authorization AVPs. DACL or downloadable ACL or VLAN. If you want to apply a VLAN, you can use ID, so just the number, or name. If you have a VLAN name, you can apply the VLAN based on its name. Or SGT, which is the security group tag. We're going to talk about this later in this class. Or airspace ACL, just for WLC. That's a special type of access list name. Okay. Yes, within the same subnet. You mean subnet assigned to the VPN clients, right? Yeah, that's the case exactly. So this way we are talking between NAD, our switch or WLC, right, and ISE server, and this is the authorization. So response from the authentication. We have authentication and then authorization as a response. And the authorization is having some AVPs for authorization like this. We need also to talk about something called a radius COA. COA is change of authorization. Okay. Usually we have this type of conversation. We talk to NAD. NAD talks with radius to AAA server. Right? So it's always this way. The NAD starts the conversation to the AAA server. That's a normal behavior. In case of change authorization, this is the only way when, or sorry, the only time when the AAA server can start the conversation and started talking to the NAD. This way. This is the COA. What's the purpose of the COA? When we want to change the authorization. Remember, for example, I authorized this user to this port with this access list. I want to change that. I want to change this access list. Then you can either tell the client to re-authenticate, or you can start this process from the ISE server by using a radius COA. But this NAD, this device, must be ready to take this packet. Okay, so it's not that, unsolicited, not authenticated at all. No. The NAD must be configured as a client to the AAA server to talk or to answer for a COA. So what can be the COA request? Can be a port flap. Right? If you want to flap the port, can be a port shutdown. or can be re-authentication, which is basically also flapping the port because the client may ignore any re-authentication messages. So it's the easiest way is to flap the port, and then the client, the supplicant, must re-authenticate. Okay. So what is the use case for COA, basically, when we use it? A couple of things. The obvious one is the session termination. Right? So if you are on a PAN, right, you are the admin, you find out a session of that client, you just click that session and say terminate that session. Then the radio COA message will be sent to the switch, and switch will shut down the port, for example, or flap the port. Session termination is actually the port shutdown. Or re-authentication. If you, for any reason, want to re-authenticate that that client, you can do that manually by just finding the session again in the admin node and click re-authenticate that session, or you can configure ISE to do re-authentication automatically. Okay, so maybe every 4 hours do some re-authentication, something like that. Another use case for COA is the posture assessment. Because the posture works this way: when someone connected to the network, then the posture agent starts and gathered some information that are required to do the posture, then deliver that information to ISE, and ISE makes decision. Okay? If the posture means okay, posture status is compliant, that's okay. We are opening this network for that user. So maybe we can change the DACL to be wide open. If the posture state is not compliant, then we can limit this, or even just disconnect this guy from the network. Okay? So we are changing the authorization based on the posture information that we get a little bit later than the original authentication took place. And another one is the profiler. For example, remember, the profiling is to about understanding what is connected to our network. So we can understand, for example, this is a host. So host, just generic host, may have this access to the network, but later, when we discover a little bit more information about this host, and now we know that this is not just regular host, it's something more, like host with Windows 10 or something like that, right? Or on this host there is a user who is in the admin group. Then we may decide to change the authorization based on the profiling or reprofiling the host. Okay? So if we are reprofiling the host, the change of authorization may also occur. Right? We will be seeing this in the lab as well. Okay, and the very first thing that I would like to start my eyes with is the integration with Active Directory. That's a very common use case. If you have Active Directory in your network, you would like to use your users from Active Directory groups to authenticate and to apply some authorization based on the groups from Active Directory. For example, if my user is from a group sales, I would like to put an access list on the switch, uh, allowing this user access to the sales resources only. If this user is from the finance, then it's gonna get access to the finance servers. If this user is from IT, maybe he will get access to some management network as well. Okay, so this is very common situation when we do this. I see the question in the chat. What does Z stands for in AUF? Okay, AUF Z, it's authorization. Okay, AUF C is for authentication. AUF Z is for authorization. Okay, and with VLAN as the AVP, you are using VLAN to put the devices in the different VLANs and segmenting them. Yes. Yeah, with any connect that doesn't work. All right, the VLAN works only with switches. Using any connect implies that the headend is Cisco device, or can we use a third-party VPN headend? Okay, any connect, generally any connect works only with Cisco. Okay, but Cisco may work with other clients. For example, if you use IDV2 for remote access and the iOS router as a headend, then you can use other clients a part of any connect, like a client built into the Windows server system, or Strong Swan on Linux, and so on. So maybe depends on the method, access method, and the headend, really. Right. So that's actually the very first thing I'm gonna do on my ISE server in the lab, is the Active Directory integration. Okay. Question is why. First, to have users and groups from Active Directory, have users groups from AD. So ISE basically reaching out to the AD using LDAP, right, and gathering groups and users and their and also the users' attributes. Because there might be not just the username, but also some user attribute, like I don't know, department, middle name, things like that. Right? Then you can use AD groups that you gathered from Active Directory for authorization of Z. Okay, so example, you can create a rule for authorization if AD external groups that the user belongs to, group equals users employees, right? Then you're gonna get the DACL of employee, or employees ACL. Okay, if user groups is finance, then you get a different access list. Okay, and finally, you can use it for user and machine authentication. Okay, I'm gonna talk about this a little bit later. That's a very important concept. But notice, first off, even if you have a user, first off, the machine is booting up. The machine is connected to this switch, and authenticating with ISE. Or may authenticate. Doesn't need to, but may authenticate. Machine alone. And then the user is authenticating. So we may have two authentications, not only one. Okay. The question is, do we have machine credentials in Active Directory? Yes, we do. So if the machine is authenticating, right, ISE is authenticating this machine against the Active Directory. Active Directory says, okay, yes. And then we can deliver a DACL for computer. Right? If the user authenticates, the process again the same, authenticates against Active Directory, and ISE is delivering DACL for user, effectively overwriting the computer access list, but we're going to talk about this. Okay, but depending on, is it machine authentication or user authentication, we may have a different access list applied to the port. Okay, what time is it? Question in the chat. There's AD attribute that shows up in the logs if AD host exists. Yes, no. Does ISE reach out to AD and check the computer group? If you have authentication for it depends on the supplicant settings. Basically, if supplicant is set to do machine authentication, then machine authentication will take place and ISE will check if the machine is in the Active Directory. And the credentials are also there. The credentials are basically the machine, once it's added to the Active Directory, it has a machine account in the Active Directory. Even though we don't see the credentials, there are some credentials, because we are using the Kerberos, we are using tickets, and so on. So we're using credentials here as well. So not only if the Active Directory, if there is an account for this host in the Active Directory, but also if the kind of password or credentials are okay too. Yeah, that shouldn't be the case. No. We'll do this configuration with later with IP chaining, so you'll see how important the IP chaining is to know that the machine is in Active Directory and the user is also in Active Directory. Otherwise, we shouldn't be able to authenticate. Okay, let's take another quick break. I'm gonna, after the break, I'm gonna give you some additional info about ISE radius packet flow. Right? So we see how radius packet is being or is flowing through the ISE. What is the decision making process? And then I will go to the lab and start configuring it from the very beginning. Okay, let's take 15 as always for coffee, and we'll be back. Okay, see you guys in 15. Okay, guys, let's continue. Next thing before I go to the lab, I would like to talk about the ISE packet flow for radius. So let's say the radius packet comes to ISE server. This is gonna be most likely access request packet, right? When we have this AVP 79 inside that with credentials. So first off, we hit something in the policy called policy set. A policy set is just um, no. Yeah, we can think about this like a use case based policy. The policy set is a set of two policies, the authentication policy and authorization policy for some use case. So for example, we usually build a policy set for the wired configure for wired authentication, for wireless authentication, for VPN authentication, maybe some more specific policy sets for other use cases as well. But in many cases, three policy sets, wired, wireless, and VPN are really useful. By default, there is one policy set called default that kind of catch-all policy set. So as I said, the policy set is basically a set of two policies, authentication policy and authorization policy. The policy set is a new, not that new concept, but at the beginning, ISE wasn't used policy sets. It's being used from ISE 1.4, I believe. Now we have 2.7 version of ISE, so policy sets are actually mandatory from ISE 2.3 onwards. So basically everybody is now using policy sets anyway, so we need to discuss that this way. Okay, so the policy set is the set of policies, right? Two policies, authentication and authorization. Let me put that as two tables. Okay. And the packet comes to ISE, and it's being first checked against the policy sets, hits one of the policy sets configured, and then goes inside the policy set, top down. First, it checks for the authentication policy, then it checks for authorization policy, and it gets out. Okay, we'll talk about this in a second. So how the authentication policy is built. Each policy is based on rules. So we have some rule, we have a condition for that rule to match, and we have, in case of authentication, ID store selected, where we need to find out our user or our endpoint or wherever, right? Something that we are authenticating. So for example, by default, we should have something like map rule, .1x rule, because those are two different authentications, and a default authentication rule. So condition for map is if that's the map authentication. How we know, or how ISE knows that this is the map authentication. Map is MAC authentication bypass. So inside the username and password, we have a MAC address. Okay? So based on that, we know that this is map, plus some other things that are inside the radius access request packet that we can guess that this is map, not regular .1x. Okay, so we are just checking if this is map, then we should look up for our user, and in this case the user is just the MAC address in, by default, internal endpoints. store. So internal endpoints is just a database of MAC addresses stored locally on ISE server. Okay. ISE server has two stores. One is called internal endpoints, another is called internal users. Right? So as name implies, the second one is for regular users. Then .1x with condition might be if this is .1x authentication, then find out the user, and it's not by default in the ID internal user store. It's something called all user ID stores. User ID stores. This all user ID stores is basically a sequence or list of different stores where we can find our users. By default, we have this points to the Active Directory, internal users, or internal users, or LDAP, or any other things that we want to put on that list. By default, the Active Directory and internal users are on the list. Okay? So we check that top down. And the default has no condition because that's the default, and it's also pointing to all user ID stores, which is just a list of available stores for authentication, user authentication. Once the user is authenticated against any of those stores, the packet will go through the authorization, and again we have some authorization rules. So there is a rule, condition, and based on matching rule, matching condition, we have a result. And this result is basically authorization profile. Now, for authorization profile is nothing more like just a container. Okay? Authorization profile. It's a container for authorization attributes like DACL, VLAN, whatever we want to send back to the switch for authorization. We put inside this profile and assign this profile to that role. For example, we may have, and that's, yeah, okay, we may have a role saying AD employees. Right? So a condition will be using some Active Directory group name. So if external group equals employees, right, then the result will be employees access. Okay, and this employees access is just a name of authorization profile configured elsewhere with the authorization attributes that's gonna be sent back to the device that the user is connected to. Okay, another rule might be for IP phones. Right, so if and we can use group of endpoints called IP phones. How do we know that the IP phone is that in a group? We can put our IP phones MAC addresses into that group manually, or we can use profiler to automatically profile that device and put it in the group, and then we can use this group name in the condition. All right, then they're gonna be the, I don't know, Cisco IP phones profile delivered. Okay. Another thing that I would like to point out here is that by default we have a rule called basic authenticated access. Basic auth access. And this rule is just checking in its condition if the authentication was successful. Right? Then if yes, we just sending permit or using permit access authorization profile, which is just giving the access to the network. And then there is a default at the bottom. There's no condition for a default, and default points to deny access. Okay. So based on where the packet hits or which rule the packet hits, let's say that was regular .1x for employee, Active Directory employee. Then obviously in the authentication policy, we hit the .1x rule. So we authenticate the user against the Active Directory. We find the user, authentication is successful. Okay. The packet goes through the authorization policy, hits the AD employees because of the condition. My employee is the user in a group employees, and then we apply this DACL. So as a result of that authentication, there's gonna be the radius packet sent back, and this packet will be the access accept because authentication was successful. Plus AVP like DACL, okay, applied to that for that user. Or if we hit the default, based on a default, they're gonna be radius. It's not based on the default, it's based on the result of the default, deny access. Okay, they're gonna be the access dash reject message, radius message, and this access reject is just saying that the authentication or authorization wasn't successful and we deny access. Do the group names in the condition, there's a question in the chat I'm reading out. Do the group names in the condition have to be created in ISE or does it pull from the Active Directory? Yes, we get them from Active Directory, and I will do that in a second. Okay. So notice that access request is going through the policy sets first, then authentication authorization inside that policy set, and the result based on what we hit here will gonna be either access accept, which is allowing us the access plus authorization, or access reject, which is denying the denying the access to the network. Right. So let's take a look at the lab. Before I go into this, let me show you how the lab is built. So we have in the lab we have ASA that it is connecting us to the internet, or FTD, or both. We have that inside the router, which is just Linux. This router is having the network here where Active Directory is located and ISE server is located. This is the network 10.10.30. This is 10.10.10. Okay, and the switch. We use the physical switch, okay, and this switch is connected to that network too. And to that switch, we have our employee PC connected to. By the way, employee PC has two connections, one to the switch, another one to this router. Okay, this is the LAN underscore SW. This is LAN underscore VM. Okay. This is gig 0 on the switch 03. I have gig 05 connected to this network. By the way, there are VLANs, like VLAN 40 is here. From the IP addresses, this is .20, this is .40. ISE is .40. The switch is .8, if I remember correctly. This router is .2. So that's the gateway out of this network. Okay, so it looks like this, more or less. Now, let me talk about lab physical connections. Because that's not that obvious. Remember, the lab is virtual, so I have ESX server. Right? On the ESX server, I have employee PC, VM. I have ISE VM, and I have Active Directory VM. And on the ESX, we have something called a vSwitch, right? A virtual switch. vSwitch. Now, those devices, virtual devices, are connected to that vSwitch. Right here, that's the VLAN 40. VLAN 40. So they are in the same network, 10.10.3.0. Okay. Employee PC is connected to the vSwitch as well, but to the different VLAN here, the VLAN 50, actually, this connection. VLAN 50. Okay. But the switch is physical device. Okay. So it's outside of this topology, and it's connected this way. It's connected to the ESX here with a ESX physical port. So this is gig 05. Okay, that's why this switch has access to VLAN 40. Notice this is the common VLAN here. The switch plus those two devices. So this is exactly this VLAN 40. But also I have another connection where my employee PC is connected to. And employee PC is connected to the USB port. This is the USB port, and there is a USB to RJ45, okay, adapter that is connected from this USB to the switch port gig 03. Okay, so this is the other, this connection. So my employee PC with one of its interfaces is like directly connected to the physical switch. With the other connection is virtually connected to the virtual switch. okay, to the virtual topology. So why is this is so complicated? Because this is the only way to make that works quite reliably. If you go to employee PC and shut down this red interface, then it's gonna pass this information to the switch, and the switch port will also go down. Okay? And in the opposite direction, same thing. If you shut down the port on the switch, that's gonna automatically shut the port on the employee PC. Okay, it will not work the same way. If someone was asking about this today. Okay, so I was asking about this, right? Because you could possibly use this. You have this ESX, right? You have some Windows machine here, VM. You use the physical interface on the server, ESX server, and you put it to the switch like this. Yes, exactly. I know. And if you do this, this is not gonna behave in the right way, right? This is not gonna shut down. It will not pass this information that this port shut this port, because here is another switch, the V switch, right? So if you shut down, you shut this down, and this is still up. That's the problem. That's the one problem. Another problem, even though if this shutdown will not work correctly, so it will not trigger the .1x process, you could still live with this connection, but you need to remember that if you want to flap this, you need to do that on both ends. You need to go to the Windows, do disable interface, go to the switch, do the port shutdown, then go back to the Windows, enable interface, and real quick go to the switch and do unshut. It should trigger the .1x and it should work, but from my experience, it's not that reliable. Sometimes it works, sometimes it doesn't work. It's really hard to tell. Okay, so that's why the only way to make it work really good is this USB to RJ45 adapter. You can buy it for $10. Okay, I have one which works for me. By the way, I've got that information from Cisco TAC. I have some colleagues there. So they have tested more than 15 different adapters, and only one works quite well, right? So I have it in the lab, and I can give you the name of it. Yeah, it's the. Let me show you. What I have is Edimax EU, this one. So that's the, let's do Amazon. This one. That one works pretty good. Okay, it's almost 20 on Amazon, but I believe on the eBay you can buy it for 10 or something. Then on the VM, you're just adding the USB port. And on the VM, you need to install regular drivers for that adapter. Right? So VM doesn't has have the VMware adapter anymore. It has ADMAX something something, right? Okay, let's go to the lab and see that in action. Um, sure that I changed the admin PC recently, so may not work everything that I wanted. So I have some the switch, and the switch port should be connected to it. So let me go to the Windows machine. There's a nice question in the chat about how we can do that in a VDI environment if we have virtualized endpoints. Um, okay, to do that okay, in the right way, you should have um, a distributed switch that is supporting .1x. That's the best solution. Yeah, from Cisco, yeah, that was the Nexus 1000, which is no longer with us, I believe. But you can still use the V switch from VMware, right? It's also they also having distributed V switch that is supporting .1x. So it should be, yeah, exactly. So that's why it's I'm not recommending that. Yeah, distributed switch is licensed, yes. Fortunately. Okay, so notice that I have some USB to fast Ethernet adapter here. That's the physical, that's the USB to this switch. So if I see it's disabled now, let me change the name of it. LAN underscore switch. So if I enable it on a switch, I should have a message that the interface went up, right? If I disable it, the interface will go down. Here we go. Yeah, that's for my lab. Yeah, and I have multiple of such adapters, like 20 or more. Okay. Anyways, let's first start with the ISE server. So my ISE server is 10.10.3.40. Sorry, 10.10.3.40. Okay, I just used some ISE server that I created, installed a couple of weeks ago. That's why the licensing is really expiring now, but you can still use it. And this is version, if you go to the about 2.7, which is the latest one. I really don't recommend that, by the way, unless you must have some features that were introduced in 2.7, and simply because the versions with a even number, they are being more longer supported, long support versions. So 2.4, 2.6, right? 2.7, not really. So the 2.8 will be the next release that will be the long supported version. 2.6 has now, I think, 6 patches, so it's pretty, pretty stable, and everything should work on 2.6 with the latest patch. And it's actually the recommended version to go for. Okay, let me start with the administration and the system deployment, so you can see what is enabled on that particular server. How my deployment looks like. So notice I have only one node. That's the list of nodes in my deployment. Right, only one node called ISE. Personas enabled, administration, monitoring, and policy service. So PAN, MNT, and PSN. Standalone, role, okay, services on the policy service node, session and profiler. So radius basically and profiler enabled. If I click on that node, you can from here see the FQDN, you can see the IP address, you can make it primary if you have if you want to install another node and make primary secondary nodes in a 2-node deployment. You can enable some additional features. Notice that administration is enabled, monitoring is enabled, policy service is enabled, and the session service and profiler is both are enabled on the PSN. If you want to disable the profiling, you can do that if you make this role of this primary. Then you can uncheck the profiling. To be honest, I don't like the profiling, to have the profiling enabled by default, because it may it may let something work even though it shouldn't by default. Okay, because when the profiler finds an endpoint, it will put that endpoint in the internal endpoints group. So it's automatically there on ISE, and the authentication will pass for that endpoint, MAB authentication, I mean. So that might be a little bit hard to understand in the beginning. So we can enable additional features like TCNAC, SXP, device admin, which is TACAX, or passive ID. Or we can enable additional persona, which is pxgrid. Okay. I don't want to disable profiling now, because when I do that, that's gonna restart the policy admin node, actually the GUI, and that will take another 10 minutes or 15 minutes to get back up. So I can do that later when we go to the break. Okay, from the licensing, as I said, I'm using the default evaluation license, which is expiring now. But by default, you have evaluation license for 100 endpoints, okay, and for 90 days, okay. And there are, as you can see, 4 different licenses: base, And in the base license, you have a lot in the base license. You have whole .1x, you have guest access, almost everything that you need for authentication and authorization in the wired, wireless, and the VPN environment. Only if you want to, more, like if you want to have a profiling rules, so profiler to profile your endpoints, to group up those endpoints, then you need to have a plus license. Also, PX Grid is in the plus license. If you want to have more than this, like posture assessment, then you need to have Apex license. Yeah, like groups of profiling based groups. And the device admin, the TACAX is licensed separately. So you need to have a TACAX license for a number of devices that you are managing. So if you have, you're managing 100 devices in your network, then you need to have 100 device admin license. Okay. Also, the newer ISE is using smart licensing. So because normally you can just import license, so you get a file and you import that file. But now you can also use the smart licensing for that. Then we have certificates. As I said, by default, we have certificates which are self-signed. Notice that here I have no secure. Certificate is invalid because it's self-signed. See, ISE demo local, it's a self-signed certificate, not trusted really. Also, we have certificates, and this is actually that certificate. Notice that the used by is the purpose of the certificate. Admin and portal. So admin means this certificate is here, used to for the administrative purpose. But also the same certificate will be used for IP authentication. So notice if I'm going to set up PIP, protected IP, the ISE server will deliver back to me its certificate, and this certificate will be self-signed. Okay? So I need to either trust this certificate or uncheck this validation on the supplicant side. I can do that. I can do both, actually. So what can I do here? I think I have. Let me check real quick. 10.10 3.20. It's my Active Directory. Oh gosh, and then I don't. Oh, okay. It was Cisco 123. Yeah. I have Active Directory certificate services running on this server. So I can request for a certificate. I can download the CA certificate. So let's try and do that properly. So I'm gonna get with a base 64, download CA certificate, to import it here locally on my Windows admin PC. See, this is the root CA. I install the certificate for the current user. I don't like this wizard to automatically select the certification store for me because it never works like expected. I always check the other option to check which store this certificate should be put into, and in this case that's going to be trusted root certificate, right? I put that in the trusted root certificate authorities. Next. Okay, that's the fingerprint of the certificate. Yes, okay. Back. Right? My certificate is now, my CA certificate is now imported. If I open it up again, this certificate, I mean, and that was in downloads, right? Cert new. Now it should be okay, right? Certificate is okay, it's trusted. Even if this is the self-certificate, but notice that root certificates are always self-signed. The question in the chat, what is the best way of setting up certificates in distributed deployment? Wildcard, space certificate per each node, like VeriSign. Depends. If you have your own PKI, then you can deliver wildcard certificate for the whole ISE, and put individual, you put the same certificate on all, or you can do per node certificate with your own PKI. I would do, even though I don't really like that. I'm a little bit against this, the wildcard certificates, but I would use wildcard certificates for that. Okay. So I just imported the certificate here. Now I'm gonna get certificate for ISE. So in this case, see what I have here, generate self-signed certificate, or I can import a certificate. I don't want to generate self-signed because I have one. I would like to use regular certificate. So I need to go and create certificate signing request. So here's the option to create certificate signing request. Click that option. Okay, what will be the certificate use? Okay, is it for administration only? Is it for IP authentication? Is it for the portal if in guest environment? Actually, I'm gonna select or leave the multi-use here. Also, we can use wildcard certificates if you want. The common name FQDN means that FQDN of ISE will be used, which is the ISE.demo.local. Organizational unit is lab, organization Micronics, city, LA, state, and country US. Okay, subject alternative name, I can put a DNS name like ISE lab local, or if wildcard is allowed, I will put asterisk that not lab, demo, sorry, demo local. That's my Active Directory. Yeah, that's the, yeah, with a subdomain that would be the most secure, obviously. Okay, key type RSA to kilo. Okay, policies that. Okay, demo local. And also, since I'm connected with the IP address, not the name, notice here, I'm gonna add another subject alternative name with IP address. 10.10.3.40. That's the IP address of my ISE server. Okay, generate that certificate signing request. Export that out. Okay, ISE multi-use PEM is the name of that file. Okay, go back to the downloads. This is the file. I will open it with Notepad. That's the certificate request. I copy that and go back to the home, request a certificate, advanced certificate request. I will put it here, paste that request here. The certificate template gonna be the web server. Okay, submit. Okay, and I will get this certificate in the base 64. Download the certificate. Keep that. Cert new one, cert. Okay. Go back to the ISE. Now go to the system certificates, and now I can import certificate. Or by the way, I can also do this way by selecting this certificate signing request and clicking bind certificate. Okay, then I can choose the file that was downloads, cert1, friendly name. I can put that name here, or I can put my ISE identity certificate. Okay, and the purpose of that certificate, admin, for administrative purposes. It says that will cause the application server to restart and deployment on all deployment nodes. Okay, so that's gonna be the downtime. IP authentication also, I would like to use it for IP authentication and for the portals. Okay, portals or guest portals. I can create here a new portal group, or just select the current portal group tag for that specific certificate, because I may have multiple certificates in the different portals, can use different certificates. What portals? Like see here, BYOD certificate, provisioning portal, hotspot portal, sponsor portal, my devices portal, self-registration, guest, and so on. We're gonna talk about those portals next week. Okay, submit. Okay, and it says that it's gonna remove the assignment from another certificate because the assignment was to the self-signed. So obviously I need to say yes. Oh, path validation phase. Make sure. Oh, sorry. Okay. Yeah. So since this certificate was issued by the CA, I need to put that in the CA in the trusted certificates first. Okay, thank you for noticing me. I forgot about this. So I'm gonna go to the trusted certificates, import, and first I'm gonna import the CA certificate. Okay, I can give it a friendly name or just leave it, and it's gonna be taken from the CN automatically. Trust for authentication with ISE. Okay. Trust for client authentication with syslog. Okay. Trusts for authentication of Cisco services. This is for if ISE is going out to the Cisco website and it's downloading some updates. So that's not the purpose of this CA. Validate certificate extensions, but not submit. Yes, I want to do that. Okay, now I should have it. Here it is. Local demo root CA. See, this is the root CA. It's still valid till 2022. Now I can get back and bind this certificate again. Choose file. Identity certificate, admin, okay. IP authentication, okay, and PX grid, not PX grid, portal with a default group here. Okay, submit that. Okay. And the system now will restart, right? So which will take like 10 minutes or so. Okay, notice I got kicked off. But that's a good opportunity to show you how we can check if the system is up and running again, back again. How we can do that? We can go to the system using PATI. ISE is 10.10 3.40. Do I have ISE here? Let me change the color real quick so you can see that. Logging in. Okay, notice that my password is expired. Current one. Password. Too similar. Okay. Okay. Notice that I now connected. From here I can do show run, like on any Cisco device, to see the configuration. Because it's now restarting, so it's taking some resources, I believe. Okay, so notice that hostname is the ISE, demo local is the domain name. The interface gig0 is configured with the IP address. Now other interfaces configured. ISE can use multiple interfaces, especially for to handle portals or profiling information. We're going to talk about this later. The name server is my DNS Active Directory, the default gateway, the NTP server, the username, the user admin user. By the way, that's quite misleading because the admin user on the CLI is different than the admin user on the GUI. Okay, you need to remember about that. So notice I changed the password for this admin user in the CLI, and I will still be using the old password for admin user on a GUI. Okay, if I would like to change the password on a GUI, I need to go inside the GUI, or from here I can also do that with a command application configure ISE. No, I think it was application. No, application reset password. Oh, here we go. Reset password. Application name ISE username admin, right, and enter. This is gonna change the password for admin user in a GUI. Okay, because this interface here, or this system, operating system, if I do show var, that's gonna show me that I have obviously 2.7 ISE version, but notice that this system is something called ADEOS version 3.0. Okay, so Cisco is using this ADE operating system, and on top of that operating system there are different applications. In this case the application is ISE. If you do show application, you'll see that ISE is the only application here. If you do show application ISE, show application status, for example, status ISE, you'll see what is the current status of ISE application, and this is gonna show you if anything is restarting or it's running correctly, or it's for some reason cannot run, for example. So this is usually takes a while. Notice that the application server here is initializing. The application server is basically that GUI that we restarted because of changing the certificate or installing the new certificate. Okay, Jeremy sent some useful information. Yes, there is a default policy in the GUI. Once the GUI is available again, I will go there and show you that the default policy is requiring, or it's about password expiration for users, including the admin user. And that's something that a lot of people is going into trouble with, because they're not changing the admin user password and it's expiring. Once the password expires, you need to have actually the CD or DVD, or you need to restart the ISE server and to run it from the image again, in order to get access to the tool that will allow you to restart this or reset this password. Okay, that's the only option when you don't have access to the CLI. But if you have access to the CLI, you need to do application reset password, right? ISE admin command. This is the command to change the password, reset the password of admin user for the GUI. Right? But yeah, a lot of people are getting into trouble because of that, I know. Right, so it's still initializing. Notice that other things are running. Some things are disabled. So those are the things related to the features that we have, right? But we have them disabled, like pxgrid, passive ID, DNS, DHCP servers, ICE message, that's running actually. But some of them are not running. PCNAC is also disabled. SXP is disabled. Most of those services are basically containers. So if you enable that, it's basically enabling inside the container. Okay, let me refresh and see if it's still initializing. This application server is actually starting like 10-15 minutes depending on the platform. In my case, that's a virtual, so it's not really fast, but okay, we have it running now. So let me get back. And I used my previous password, not the new password. Okay, it still show. Oh, okay. See, it's saying that this is the certificate is using weak algorithm, signature algorithm. That's why it's saying that the certificate is wrong, even though the certificate is now, see, the subject ISE demo local issuer is root CA, everything should be fine, but it's showing me this the certificate is not really good because the weak. Yeah, it's because SHA-1. Yes. Yeah, I have old Active Directory. It's 2008 Active Directory, and it's still using SHA-1. Okay, let me proceed with that. Yes, I believe so. And recently, especially recently, ICE and FTD, FMC, all Cisco current versions of the products changed the cipher suites to be more secure, and they are neglecting the old uh, or ciphers. Okay, that's the information about my expiring licensing. Not really important here. Okay, so that was their certificate. So let's start configuring something. So first off, even though we have many different options here, don't be scared, okay, too quick. It's actually really simple, but you need to understand where is what, okay, and it takes some time. So first, by the way, about this admin access and policy, right? I should tell you. So when we go to the administration admin access, okay, we have a password policy here. Authentication method is password based, password policy, right? And we have information about how new password must be created. Is it lowercase, uppercase, numeric, and so on. Okay, and account disable policy, lock and suspend settings. So see, suspend or lock account with incorrect logins, okay, and so on. But also in the case of the only admin user I have currently is the admin user. No, it's under the settings, I believe. Settings and okay, here, by the way, I will allow SHA-1 ciphers because I will use that in a certificate. So I will enable that. Okay, here. Okay, it's not under system, it's under identity management settings. We have user authentication settings, password policy for users that we create locally. Okay. And we have password lifetime disable user account after 60 days. Uh, okay, I think it was now changed a little bit because in the previous versions, that's the 2.7, the latest one, right? We have that only about users, but in the previous versions, we had that information here to log the, the admin user as well. So now I think it's in a different place. It might be here in the admin access policy. We don't have that expiration, I think. So I wonder when they changed that. It the recent change or something took place, you know, 2 versions ago, and I didn't notice. Not sure. Yeah, okay. Yeah, let's move on and start with integration with Active Directory first. So identity management. I have identities. Yeah, we will do lunch break in a second. Okay, let me finish that. So we have a user store. By the way, I have some user here, but by default it's not there. I have a user help because I was just testing something here. So by default there are no users. So let me get rid of that user. Okay, no users. I'm going to integrate with Active Directory. So I go to the external identity sources. I have 2008 here, but I'm now testing it on 2016. I saw that it's very popular now at the customers. Yeah. So yeah, I thinking about changing the Active Directory here in our environment to 2016 because that's 2008 is too old now. Notice I have some Active Directory already here. I will get rid of that just to show you the process from the very beginning. Okay. Okay, so no Active Directories. By default, I click Add, give it a name like AD1, domain, demo local, submit. Based on the DNS configuration on ISE, ISE should automatically find the Active Directory and Active Directory IP address and join to the Active Directory. So it's asking me if I would like to join now. Yes. That's going to create an ISE domain account. Administrator. Okay, it's joined successfully. Now I can go to the groups and grab groups from Active Directory or fetch those groups. I can filter groups by something if I want to, or just click retrieve all groups and I get all groups here. I can select all of them, or I can just select the groups that I would like to use in my further in the configuration of policies. So I'm gonna definitely use some groups like contractors, employees. I'm gonna use groups like domain computers, domain users possibly. Come on. Okay, that's enough. Okay, so only four user groups will be taken. I can save that. I can also grab some attributes for a specific user or users. Right, so if I go and, for example, let me see employee or maybe contractor one user. I'm retrieving now all attributes for that specific user. And let me something like I don't know. Okay, I will not use that now. I will use that later, so we can maybe use those attributes for something else. Okay, so let's skip that. So I have my Active Directory now connection or integration done. Now I go to the policy sets. By default, I have that default policy set. If I click this icon here in the view column, I will go into that policy set and I have authentication policy and authorization policy. Authentication policy, see, there are three default rules: map.1x and default. Map is just catching the map for wireless and wired, and it's pointing to internal endpoints for users. .1x is catching the .1x in wireless and wired, and it's using all user ID stores list of possible stores. The same with default. Okay? And the authorization policy, there are more than I just showed you on the screen, but notice there is something enabled. Those three are enabled. Most of those rules are disabled. They are just created by Cisco for you to use that if you want to. I prefer to create my rules, manually. So there is some rule for wireless blacklist, for profiled IP phones. We are using, see, the profile Cisco IP phone group. For non-Cisco IP phones, then a couple of groups, rules, sorry, not enabled. And at the bottom we have basic authenticated access, which just with or which is just checking if the network access authentication passed. If it passed, we just get permit access, and the default is deny access. So that's the default policy set. I'm gonna create another policy set, but I will do that after the break. So after the lunch break, we're gonna create a new policy set for wired. We will create some basic configuration to authenticate and authorize the users. Then we check if the native supplicant works and we'll see that in action. Okay, so that's the plan for past the lunch. Okay, so lunch break, 30 minutes as always, and see you guys in 30. Okay, guys, let's continue. So, next thing I wanted to do in the lab is actually add a new policy set. I click this big plus symbol to add it. I'm gonna call it wired. I need to select what are the available protocols to be used by this wired policy set, and obviously I need to add the condition. So I click that and will pop up something called the condition studio. This is for those of you who are not familiar with it, or maybe some of you are using ISE but with version 2.2 for example, or because everything changed, this editor changed into that 3, I believe. 3 or 4, I don't remember exactly, but anyway, so we have a new condition studio, a new condition builder, let's call it this way. So on the left we have a kind of library of different conditions that we could use. On the right we have options to manually build the condition. So in my case, I'm configuring the wired policy set, so I want a wired 802.1x to go there. So basically, the easiest way to do that is basically use the pre-built condition from the library here. I just drag and drop this on the right side. That's going to be wired 802.1x and also wired mab. We'll use both, and obviously that cannot exist at the same time, so there must be logical OR between those two conditions. I click use. Do not click save here, because if you click save here, that means you want to save this compound condition, let's call it, in the library on the left. You need to use it here. So click use, green use icon or button at the bottom. Okay, so into the wired policy set, all wired 8.1x and wired map authentications will go. So I'm gonna save it and now go into that policy set. Inside that policy set, I have authentication and authorization policies. Authentication policies just having now a default setting, so I will add new. I will divide those two to .1x authentication, and the condition will be just .1x from the library again. Okay, wired 802.1x. Here, use. Okay, so what user data store I would like to use? Not the internal users. I would like to use Active Directory. So I will choose my AD1, the object that was created once I integrated my ISE with Active Directory. Okay, I'm gonna create another one by clicking this plus. This plus here will add at the top. but it doesn't really matter in this case. MAB authentication. In this case, that's going to be wired MAB condition. Okay, wired MAB. Okay, and for wired map, I'm gonna be using internal endpoints. That's the store, internal store with MAC addresses. Okay, and the default, I will change the default to deny access. I don't want to use anybody by default. I want to have full control over what is going on here. That's gonna be my authentication. For authorization, there is a default rule, just denying access. I will add another one for my employees. I'm gonna say AD employees. Click add as a condition. Now, obviously, I don't have any condition, pre-built condition in the library. I need to create my own condition. So I click that option, click to add an attribute. Okay, by default, when you first time use it, you're gonna see this help. Close it. And now you have all possible attributes that you could use. You can divide those attributes by clicking those individual groups of attributes. For example, if you're looking for attributes related to identity group, you just click this and you're gonna filter. This is gonna filter this list to show you just attributes related to the identity groups. If you're looking for something related to the network device that is being used for authorization or authentication authorization, then it's gonna filter this list. Okay, or alternatively, you can unclick this. So notice when I once clicked, that's gonna filter this list, but when I click again, that's gonna unfilter it. Then I can use this field, the attribute, and that just type something like use case. Right? If I'm looking for something specific, I have this. This is the way to find it quickly. Okay. Now I'm looking for a group, so that's gonna be identity of my users. So I click the identity group, and I'm looking for the external groups in the Active Directory. So I select this AD1 external groups equals, and then from that list I should see only the 4 groups that I already fetched from the Active Directory. Come on. Okay, let me start over. If you want to delete this, you have this small icon with X in it. And just clear the condition and select it again. not showing up. No, now something's wrong with that data. I think it's something wrong with my either the web browser or something else showing up, but it's not showing everything. Yeah, sometimes Firefox works better. By the way, I don't have Firefox here. Sorry, it's Polish. I want to change that to be in. Okay, notice that now I have unknown issuer message with a certificate. That's because Firefox is using its own certificate store, right? It's not using store that is built into the operating system. So if I want to make that work, I would need to go to the options certificates and import my CA certificate to the Firefox store. View certificates, authorities, import, um, downloads. That was the CA certificate. Okay. Have it imported. Let me refresh. Now I don't have any message. See? And it looked like it's verified. And it's not showing that it's wrong because of the old SHA-1 cipher. Right? Its certificate is trusted, basically. See, demo local. Okay. Try with Firefox then. Go to the policy sets. Inside my wired policy set, I was configuring authorization policy, ID employees, edition gonna be ID1 external groups. Now much better. And employees. Use it. And the result. Now result is the authorization profile. Profile with some authorization attributes. So I can click plus here and create a new authorization profile if I wish. Okay, I can give it a name like employees underscore profile. Right. DACL name, I'm gonna send the DACL name of a name permit all IPv4 traffic for this moment. And just save it. And now I can select it again, employees profile. That was the name. Okay, security group, we're gonna be talking about this later in this class. Let's start with that first. Okay. Now I go to my employee PC. It's in the correct place actually. And I go to the network settings. For Ethernet, I have two. So what I'm going to do first, I'm gonna disable that LAN VM. I'm gonna enable LAN switch, so connection that is directly connected to the switch. I go to the properties of that LAN switch, and I have some, basic configuration here, but I don't see an authentication tab here. Okay, so that means I don't have supplicant enabled on this machine. In order to make the supplicant enable, I need to go to the services. I'm going to enable native supplicant, the supplicant that is built into the operating system. Right? So I'm going to the services, and there is a service called wired autoconfig. Notice that this is the manual startup, and the wired autoconfig service is responsible for performing 802.1x authentication on Ethernet interfaces, and by default this service is disabled. This is different than wireless, because notice that there is also WLAN autoconfig service which is running, and that's actually the .1x authentication for wireless. Okay, and that's automatically running, but not for the wired. So I'm gonna change this to be automatically started. I'm gonna start it now and click OK. Okay, automatic running now. So when I go back, notice that we have attempting to authenticate message. When I go to the properties, I now have authentication tab in properties of my network card. Notice that .1x is automatically enabled, and the authentication method is PEEP selected for the outer method. When we go into settings, we see that the selected authentication method is IPMSJAP. That's the inner method. Okay, and then when I click configure next to it, it says automatically use my Windows logon name and password. So now I'm not in a domain. This computer is just a Cisco local user. This is not a domain computer, so I cannot use domain user for authentication, right? So I will leave this unchecked. Another thing that we need to see here or change this is to verify the server's identity by validating the certificate. Remember, the PEEP works like SSL. So the server, in this case ISE, will deliver its certificate to us, and we need to be able to verify that certificate, right? Especially the signature. That's why we should have CA's certificate um, locally here, right? Or we can disable this check. Can also do this, right? So we can uncheck this to not verify server certificate. So I will first uncheck this and see if that works, and then I will install the certificate and get back and enable that option. Okay. So that's the first thing. Another thing is, remember my credentials for connection each time I'm logged in. I will uncheck this because I want to be, I want the system to keep asking me for the authentication. Fallback to unauthorized, that's okay. In the additional settings, notice that I need to specify what authentication mode I would like to use. User or computer authentication, or just computer authentication, or user authentication. In this case, I will leave user or computer authentication because I want to authenticate both. Okay, okay. Now I have a message of attempting to authenticate, and notice this keeps me asking to sign in. So I can use employee one. That's my Active Directory user with its password. No, the computer authentication will be .1x as well. It's not Kerberos. Okay, notice that I cannot authenticate, right? That's okay. Let's see what's going on the ISE side. Everything that we need to look at is the operations radius live logs. When I click that, I should see some logs telling me what's going on. And notice that I have many messages here, all messages with the red authentication failed status. And the failure reason for that is, see this, could not find the network device or AAA client while accessing NAS by IP during authentication. Okay. Verify that the network device is configured. So basically the problem is that I don't have my switch added as a network device. Okay, that's the problem. So again, could not find network device or AAA client. I see this failure reason here as an additional column because I choose that. Normally you don't see it. You need to, in order to see that message, you need to go to the details. You click that details icon, and inside the details you see what is the problem. Radius request dropped, could not locate network device. Okay, I see this failure reason because I did this configuration already. I clicked this gear icon, and on this list of available columns, I choose the column failure reason. I also choose the column authentication method and authentication protocol. Those three are new columns that I selected here on that list and click go. Okay, that's because I want to see more information in those logs. So you'll see that in a moment. This is very useful. Okay, so now we know that the problem is that we don't have switch added as a network device. So I go to the network devices, administration, network resources, network devices, and I click add to add my AAA client, my switch. I call it switch. IP address of the switch is actually, let me check that. Show IP interface brief, 10.10.3.8. That's the IP address of the switch, 10.10.3.8. Okay, I choose the radius authentication, shared secret 1234 QWER. Show it. Okay, and submit. Now I have my switch added as a network device. Okay, so get back to the live logs, get back to my employee PC, and provide the credentials again. Okay, now it says authentication failed. Maybe the typo. Yes, thanks for that. Anyways, we'll see the different message eventually. Oh, here we go. We see now the message failure reason says subject not found in the applicable identity store. Notice what is the authentication method .1x. Notice what is the authentication protocol. It's PEEP as the outer method and IPMSCHUB v2 as an inner method. And we also see what authentication policy and authorization policy applied this to this particular session. Okay, maybe I mistyped that. Let me try again. The easiest way is to just flap the interface. So I'm going to disable it and re-enable. I just want to show you different options, different troubleshooting steps. Okay, now it should be correct. Employee 1. It's showing me authentication failed. Okay, see. Right, see, now we see the employee 1 as an identity, but we see some message next to it saying access request is missing Cisco AV per attribute with the value AAA event equals ACL download. What's going on here? To better understand that, what's going on here, we need to take a look how the ACL download works. Okay, so let me show you the theory first, and you'll see step by step how we can fix that and troubleshoot. So as you can see, I don't want you to see just a working configuration. That's not my style of teaching, right? I want to do that step by step with all the possible, maybe not all, but some possible mistakes, problems, issues that you can troubleshoot. So how the ACL download works. what we have a switch connected host to that switch and the ISE server, right? So .1x started. Switch is already configured, okay? I'm not saying it's configured in the right way, but it's probably not, but it's configured for .1x, okay? We're gonna be talking about the correct switch configuration. Now let's focus on what's going on, why it doesn't work. So we have a radius access request on this side, right? This radius access request points to the policy set wired in our case, right? Now it's going through the authentication rules. Then it's going through the authorization rules. Right? And in the authorization rules, it hit the AD employees rule, right? And the AD employees rule says authentication authorization profile, right? And inside that profile is the DACL, right? This is what we had. Let me show you that again. Policy, wired policy set, authorization policy. We hit the AD employees, right? And it's giving us employees profile. And what's inside that profile? We can go to the policy elements results, and under the authorization profiles, I can find this profile. It was called employees profile. You can see it's giving us the DACL name of permit all IPv4 traffic. Right? This DACL, I can see it under the downloadable ACLs. If I click permit all IPv4 traffic, it says it cannot be edited because it's a default. Sorry, but I can duplicate, so you'll see what's inside. Permit IP any basically, right? So yeah, so we got that DACL name. Now the process is, based on this, the response will be the radius access accept. Right, this message, because the authentication passed correctly and the authorization is also okay with the AVP inside of a DACL name. So the DACL that we put here is gonna be here as the AVP, DACL name. Okay, so not the DACL entries like permit IP any or whatever we have inside the DACL, just the name of that DACL. Okay, now the next process started. Now the switch got information, okay, I need to download the DACL. So the switch initiates another radius access request. Okay, when the AVP of username equals to the DACL name that we want to download. Okay, plus here supposed to send another AVP called event equal ACL underscore or I think it's a minus or hyphen download. This AVP must be added by the switch to differentiate this access request from a regular access request from a user, because this access request is just to download the access list entries, not to authenticate the user. Okay, so it's a special type of AVP that is telling the ISE that the ISE should deliver the DACL entries to the switch. So again, now ISE is sending access accept. Okay, and then in the AVPs we have entries like permit, AP, any, or whatever we have inside this access list. Now, notice that in our case, in the log, next to this download of the access list, the failure reason is saying the access request is missing Cisco AV pair attribute with a value event equals ACL download. Right? So our switch did not include this in the access request. This is called VSA. This is a vendor specific attribute. And on the switch, we need to tell the switch to include that vendor specific attribute. How we can do that? I go to the switch, show run section VSA. We don't have any VSA commands. There should be a command radius maybe VSA no, radius should be radius server, I believe. Yeah, radius server VSA send authentication. Okay, this command is needed because otherwise the switch will not include that information, that AVP, that this is about downloading the access list. Okay, let's try again then. Okay, it started automatically for me, so oh, see, now it looks like this is much better. Let me refresh. Okay, let's change the for 5 minutes the log. Okay, so we see only the logs that are current ones. So notice, first off, we have employee 1 authentication with IP and MSCHAP inside. Okay, we been authenticated against this authentication role, and this authorized against this authorization role. We got the employee's profile or attributes from employee's profile. Then there was another DACL download event, and finally we have a session. So this blue icon is the session that was created for that user. Okay, so now it works. It works okay. Let's go further. Now I would like to authenticate a machine. So if I go back and let's say I'm gonna sign out. Okay, Mir is asking some questions. DACLs require to use of .1x. Um, yes, but you can also use MAB for to get the DACL, or passive ID as well, which is really using MAB to apply that. Second, DACL only work with wired or with wireless as well? No, just wired, just on the switches. Uh, Wireless LAN controllers do not support DACLs. There is one exception though. If you have a switch with a built-in wireless controller, I think it's 3850 with some wireless controllers built in, then this controller built into the switch supports DACLs. Okay. So WLC can get just the ACL name and can apply this ACL, but it must be configured on the WLC itself. Okay. Cannot be downloaded from ISE. Okay. Notice that now I signed out, logged out, right? So I have some messages here that the employee dash PC, notice this is the host now, trying to authenticate. And it's trying to authenticate with PIP and MS CHAP. And what I get here, subject not found in applicable identity store. Okay. Why is that? Because this host is standalone. It's not in the Active Directory. Right? So I would need to add this host to the Active Directory in order to make this work, because this identity does not exist in the Active Directory. So I can go back here. And I need to add my employee PC or join to the Active Directory. And that's why I have this second interface that is working in the virtual environment, so I can use this interface to join the domain without being authenticated with .1x. Let me go to the interfaces. I'm going to disable that interface, physical interface. I re-enable the VM interface. It's also attempting to authenticate, so I can just disable the authentication, that interface, to not being authenticated. Okay, I'm connected. Yeah, me too. Gosh, I hate this Windows 10 with I'm not using Windows just in lab, but even in the lab, it's annoying. Okay, let me check. Ping 10.10.3.20, that's my Active Directory. IP config, let's check what is the okay, default gateway is 9.2. What is the DNS? Okay, DNS is 3.20. Okay, so my Active Directory is the DNS actually. So I can go to I hate that. Okay, domain is demo local. Okay, so I joined the domain. Restart. Gosh, kill me. So I need to now sign in as a different user, employee 1, domain user. Okay, so we're getting ready. Let's move on. And in the policy sets, notice that I still don't have authorization policy for domain computer. I just have authorization policies for employees. So what I need to do, I need to add another rule for computer authorization. So AD computers should automatically belong to the domain computers group in the Active Directory. So again, external groups. This time, that's going to be domain computers. And then the results. I'm going to add, you know what, I'm going to create some, let me just permit access so I don't need to, I will not lose that configuration, but I will create separate access lists. So let me go to the policy elements results. Under the authorization, I have DACLs that I can create. Actually, I have two DACLs already created. One is called ACL user, that is just permitting everything, IP any, and I have ACL machine. That is just permitting ICMP, UDP any, so to work DHCP and DNS, and some TCP to host 3.20, which is my Active Directory. Okay, so I will reuse those DACLs. I'm gonna create authorization profiles. Actually, I have two authorization profiles already created. One is AD user, that is sending this DACL ACL user, right? It's also sending VLAN information. Okay, I don't want that. Rid of this, no other attributes. Save it. Normally, I should configure that from the beginning, but I already have that configuration, so to speed up a little bit, I will just reuse it. The ACL machine will be delivered for the machine, and that's it. That's only one thing. So now I get back to my policy sets and then apply in the authorization. In the AD employees, I will apply, that was AD user, not employees anymore, so I will just get rid of that. And for machine, AD machine authorization, like this. Okay. In this profile AD user, I have access list for user permitting IP any. On this, I have DACL for machine, just permitting ICMP, some other things. Save. back to the employee PC, and now I need to enable that adapter. Okay, so I'm gonna disable this one, and okay, now I'm just the user, so I don't have this administrative access to disable network interface. I need to authenticate. Wrong password. So it should authenticate. Notice that it's asking me to provide username and password. I'll just cancel that. Go to the properties again. Because I had that option to not send automatically user credentials. See, under the MS Chat, I need to select this to automatically use my Windows logon name and password. It should not ask me again. Okay, authenticated again. Looks great. Let's check the live logs. And here we go. Now it's demo slash employee one. That means this is the Active Directory user. Yes. So good question. And in the chat, I will just about showing you this. So this is the user authentication. Now when I sign out again, so I'm gonna log off. Now there should be another authentication for a machine. Notice this. Now this is the host, employee PC demo local. ACL machine was downloaded and the session for a host. And I can also verify the same on the switch. There is a nice command on the switch to verify all that stuff called show authentication session for interface gig03 in this case. Notice that my gig03 is the IP address of this, and the username is employee PC demo local. That's the host, not the user. Authorization was successful. Notice the access list applied is this, and inside the access list name there is the ACL underscore machine, the access list taken from the ISE server. So the answer to the question from Ramider is yes, simply because the user authentication result will overwrite the previous result of machine authentication. That's the problem generally. Okay, so notice that now I'm authenticated as a machine. I have this access list. Can I see this access list? Show IP access list. Okay, Okay, amongst other access lists, I have my access list for machine. Right? This is how exactly this access list looks on the ISE server. Permit ICMP, UDP, and DCP to that one IP address. But this is not the way how this access list is actually applied, or how it looks being applied to the interface. There is another command, show IP access list for the specific interface. And now notice that this access list, this is exactly the same access list, but notice it has host as a source. So source any was replaced by the host's IP address. Okay, that's very important thing. What is responsible for that? Notice in the show session, we have that IP address. Okay, how do we know that there is that IP address on the host? How Switch knows that? Switch knows that based on some feature configured here called IP device tracking. Show IP device tracking all. IP device tracking is a nice feature. It's not related to .1x. It's just a feature on the switch that you can use to understand or to find out what is the IP address from on the host connected to a specific port. So, for example, in our case, see the gig 03, the current IP address there is this one. Okay, this is pretty cool. To enable that, it's just one command, IP device tracking, and that's it. And it's actually very important to have it enabled, and some people have problems with that because they forget about this command. It's very important in case of .1x, because once you get the DACL on a switch, in order to apply it to the interface, the switch must replace the source any with the IP address of the host that is currently connected to that host, to that port on the switch. Okay, so we need to have that. If we don't have IP device tracking, this access list will not be able to be applied to that interface. It will be downloaded to the switch, but will never be applied to the interface. Oh, thanks, Nikit. Okay. So hopefully we have that command here working fine. Right? So notice now I have a session as my host, right? Now when I go back and authenticate as an employee, as a user, this is gonna trigger another authentication. Notice authentication successful for client, right? Authentication results success from .1x, and see the new access list it being downloaded, right? And applied, because we have this IP address and all that stuff. So if I now check the show authentication session for interface, now the user is my employee 1. and I have different access list now. And if I check the access list, how it looks like applied to the interface, it's just this. Okay. So now we have a fully open network for our client and obviously for the host, because this authentication and authorization result overwritten the previous authentication and authorization. Yes, you're right about this SVI and delays and stuff like that, because there is an issue with IP device tracking sometimes, because it's based on the ARP, and sometimes it's showing the duplicate yeah, information that exactly. Okay, so now I should have, when I already refreshed, employee PC, not employee PC anymore, employee one, and the new access list applied to the interface. Okay, so now back to the, for a second, to the how DACL download work. What if we change the DACL on the ISE side? How the switch knows that there is a new DACL? Because, or maybe one step back, why this process is like doubled instead of just sending the DACL entries in this first access accept message? This is the optimization thing, because what if this switch already have that DACL, right? It might be the case that we have like maybe 40 different people connected to that switch already, and they already use the same access list. Do we really need to re-download this access list for another time? Obviously not. So that's why we are just sending the DACL name, right? If the DACL is on the switch already, the switch will not re-download that DACL, right? But if there is no such access list, then this process in blue will start to download the ACL. Okay, now what if we had that DACL on the switch already, but we changed something on ISE? I mean something inside this DACL, added some entry or deleted some entry. How switch will know that there is a new DACL name or new DACL entry? Notice that if we take a look at the DACL applied, we have this suffix here, which looks like kind of hash or part of hash. Right? Based on this, switch knows that there is a new ACL to be downloaded from ISE, because we will have something here like X7BAC8, right? Something like that. So switch knows, okay, there is something new, because once we change something inside this DACL on ISE, then this suffix will change. So the DACL name will change as well. And then the switch needs to re-download that the new ACL. Okay, a question in the chat. How often the switch checks the validity of ACL with ICE? In other words, when an access list is changed on ICE, is it downloaded to the switch immediately? No. No, only during the new authentication and authorization. It's not an automatic way of checking something on the ICE side, no. Yeah, so if you need to make a change, you need to re-authenticate, yes. But you can re-authenticate this way, using COA. Notice this session here. This session created means that we have live session. If you click, instead of live logs, you go to live sessions, you'll see only the live session for this user. And then you have, in the action column, you have show COA actions. When you click this pointer icon next to it, you can do session re-authentication, you can terminate with port bounce, re-authenticate. See that like this. If I click session re-authentication, notice that message here, COA action was sent. That should re-authenticate. And notice this, session authentication successful. Again, we have re-authenticated session. So if I change something, right, in the, is there a re-out all or just per session? Okay, it's a per session this way. You could possibly use re-authentication. Where was it? Let me check real quick. You can do that two different ways. A part of that, you can configure session re-authentication on the client side, not the client side, but the switch side. So, for example, here you will see the session timeout. So you can configure this setting so that switch will trigger the re-authentication every 1 hour, for example. Okay, it's gonna be seamless for a user because it's gonna be in the background. Just the supplicant will just take the user credentials automatically in the background and send them to the ISE for verification. That's it. So you can use this way, the session timeout, or you can use that with the use of COA from the ICE side, and this is called PRA. Oh gosh, it's periodic re-authentication. Oh, periodic re-authentication. But I need to think for a second. Where is that configuration? remember where is that option. Because it's usually used for posture. If you want to, check if the posture is still the same, that's the PRA is usually used for, but it can be also administration system setting posture. Okay, it's under the posture. That's why I cannot see. Administration system setting posture. The posture reassessments. Oh. So we can basically create a reassessment configuration for a specific user identity groups, and we can enable the interval for reauthentication. That's another option. So basically 3 options for that. That's really interesting question. People basically rely on that. Even if you change the ACL, the user will probably re-authenticate or by maybe tomorrow, right, by restarting the Windows system or something like that. Or you could possibly also do the flap of, you could just shut and unshut the interface on a switch port, right? But with some script, but that's gonna be too I think it's not good to do that this way. Reauthentication shouldn't change anything for a user, but port flap will obviously do some harm. Okay. Another thing that I wanted to talk about is the host modes that we can configure and use. Host mode. What does it mean? It means depending on how many hosts you have connected to a switch port, you may decide to authenticate all hosts or just one host or one MAC address or multiple MAC addresses. Okay, by default, the default setting on a switch port is the single host. That's the default. Which means that there only can be one MAC address visible on that switch port. Right? One MAC. And that's it. So one MAC address can be authenticated. Okay. What if another MAC address will pop up? Then the switch will go to disable. Okay. So you need to be careful with that. That's why the single host, it's not really common configuration on the switch port. Let me show you the switch port config here. Show run interface gig03. And notice we have host mode configured with something called multi-auth. Okay, so it's not a default single, it's a multi-auth. What does it mean? Second option, multi-auth. Multi-auth is in the situation that you have multiple MAC addresses on the one switch port. Okay, it can be case that this there is another switch or another hub or some device here where multiple hosts are connected to. Right, so we, instead of one MAC address, we now see 3 MAC addresses on one switch port. Another very common situation is if you have switch and to that switch port there is an IP phone connected. You have IP phone and you have a host connected to that IP phone. Then again, 2 MAC addresses, MAC address for PC and MAC address for IP phone. Right? So what will happen in that case? Multi-auth means that multiple authentications will take place. So each MAC address will have its own authentication. Okay, but as a result of authorization is the DACL. What if we will get 2 DACLs for 2 authentications? And how we can apply those ACLs to the switch port? Because there is only one by default. There is only one access list that can be applied to a switch port at a given time, right? You cannot apply as many as many access lists as you want to the switch port. So how we can deal with that? Let me explain this. Let's say we have, in this case, with the IP phone and the PC, we have 2 DACLs. DACL PC that is permitting some, I don't know, TCP any equal 80, right? So basically permitting HTTP traffic. And we have a DACL for IP phone. And this is permitting IP any. Right? If we are authenticating both, we're gonna be the ACL applied here, and this ACL will be combined. Okay, so we will have permit. Let's say the phone was the first one. Permit IP any. And then was the PC. Permit TCP any equal 80. If we combine those 2 access lists together, notice that the first permit IP any will allow everything. Right? So the host will get the full access to everything. How we can limit the host then? It's done automatically. Remember IP device tracking? Based on the IP device tracking, we have IP addresses. Here, IP1. Let me change the color maybe. Visible. IP1 IP2. Right? So in this case, the source any will be replaced. That was for the phone, right? So by IP2. This any will be replaced by IP1. And now, even if those two ACLs are combined into one, this is gonna still work as expected, right? The host will not get access to everything. It will just get access to port 80. Okay, so remember, right, this is based on IP device tracking. IP in my opinion, this is the most common configuration, multi-auth. Option number 3 is multi-host. What's the difference? Let's say we have a host connected to the switch port. Okay, and obviously there is one MAC address here. But what if this host has some virtual machines on it? Right? Then this host has some MAC address, plus those virtual machines have their own MAC addresses. So how we can deal with that? We can either use multi-auth, but if you choose to use multi-auth, that means you must enable .1x supplicant on those virtual hosts as well, on the VMs. Right? It would be nice to have an option to just authenticate this guy and then let anybody else, work on top of that. And this is exactly what multi-host is about. Only one authentication is required to open the port. Okay, question in chat. Can you apply different SGT tags in multi-auth hosts? You can, but not sure. Okay, I need to now think about it because I was doing this, but I don't remember. The answer is yes, you can. Yeah, I remember that I had two hosts on the same interface with multi authentication. I authenticated both, and they both had different tags because now the traffic leaving that host will be basically tagged with a number. Yeah, works. Yes, and another number 4. I would like to put that on this same screen here. Whiteboard is called MDA, multi-domain authentication. Multi-domain authentication. That's quite similar to multi-auth, but works a little bit different. It's reserved for a situation when you have a host with IP phone. Connected to the switch port. So in this case, we are dividing our two authentications into the different domains. This is the data domain. This is the voice domain. So it's not, this domain doesn't mean this is related to Active Directory or something like that. No, that's not Active Directory domain. It's a data or voice domain. And we can now change what will be the authentication per domain. Voice may use MAB, data can use .1x. Okay? So basically, two domains means two authentications. Right? And we can also limit depending on the software, because sometimes not possible. On some switches, it's possible to even limit number of MAC addresses on a data domain or per domain. Okay, so that's quite popular if you have Cisco environment, multi-domain. If you don't have Cisco IP phone, you use multi-auth basically. Yeah. Okay, and another thing is the phased deployment that we have now. Phased deployment. So as I remember, my first .1x implementation in my career, it was in 2003, something like that. So a while ago, right? 17 years ago. And at that time, there was no ISE server available, but let me take a look at the .1x history real quick. It will make you understand of something important, I think. So in 2003, right, it wasn't .1x or Cisco ISE and stuff like that. This actually, the whole idea was really close to what we have today. We called this solution NAC framework. Right? That solution to authenticate endpoints and users before they get access to the network. That was the Network Admission Control Framework, 2003. The original idea was pretty fine. It was still that the edge device, like a switch, right, will authenticate actually or pass the authentication to the ACS at that time. There was no ISE, but ACS. And the ACS will deliver the access list to the switch, and the switch will apply the access list to the switch port. So exactly the same that we have today. The problem with that NAC framework was that you had no way to enable that in any testing mode or monitor mode. You just had to enable or disable the whole feature. Okay? So you couldn't make any mistake, because if you made a mistake, then nothing worked, right? So, and I had that situation actually. I remember with my colleague, we spent like 2 or more weeks on setting the ACS to be working with switches in some company, for some client. And we had to, test everything if it's working, if it was working in the lab and so on. We implemented that on the production, and the next day nobody could access to the network. Like 500 people couldn't access the network. So that was really, really bad. But uh, at that time, the problem was one. The switches, the software on switches was no, uh, created to support .1x in a good way. I mean, there were a lot of bugs, unsupported features. Sometimes the switch could even, reload itself because of some packet. It was really, really, really bad in case of implementation. So, this guys from the security created a nice solution, but guys from the switching uh, business unit, they didn't create a good code to support that. Okay. More than this, some switches supported port access lists, some switches didn't. So it was really, really messy and not ready to be a solution at that time. Okay. That's why, because it didn't work well, Cisco decided in 2005 to buy a company, and they bought NAC appliances. So instead of using some edge devices as an enforcement point, okay, to the network, you just put another device. You have that switch here still, but this switch is not doing any authentication. You put some NAC appliance behind it, okay, and then there's a network here. And this NAC appliance is there to authenticate and to open the traffic to go through. So it was working. That was much better in case of being user friendly and stuff like that. But it required a lot of NAC appliances, different kind of NAC appliances. So there was a NAC appliance for .1x. There was a separate NAC appliance for guest access. There was a separate NAC appliance for any other things, like 4 or 5 different appliances. But Cisco learned the lesson, and when they started development of ISE, they included everything that was really important here, both from the NAC framework lesson and from the NAC appliances. That's why ISE from the very beginning had the guest access, other, features that were taken basically from those NAC appliances. But they get back to the original idea, when the networking edge device is the enforcement point. But now they made it better, okay? Better. So basically the original idea is still with us, but they make it better because they give us a monitor mode of deployment. So we start with monitor mode, then we go to something called low impact mode. And finally, when we're ready, we go to the closed mode. Okay. With NAC framework, there was only the closed mode. Now we have 3 steps, 3 phases of deployment. Okay, the monitor mode is basically all those modes depends on the configuration on the switch port. Right? So if you go to the switch port, monitor mode has authentication open command on it. Authentication open. What does it mean? It means that the port will remain open even if host or a user failed its authentication. Okay. Port even if host or user failed its authentication. Obviously, the problem might be on the other end, like on the Windows machine, when the Windows machine, based on the failed authentication, can close the interface and so on. But from the switch perspective, it works this way. Okay. Low impact is still authentication open with a default access list applied. Right? So it works this way. So if authentication failed, then you fall back to the default access list. If the authentication is successful, the default ACL will be overwritten by the DACL that you got from the from ISE. Right? So if authentication failed, right, default ACL is limiting, right? But if authentication success, the default ACL is overwritten by the ACL. And the closed mode is basically no authentication open. Just the authentication command authentication port control auto. Authentication port control auto. Okay. So that works typical. If authentication failed, port closed. If authentication success, port opened with the ACL. Okay, so we usually start with the monitor mode. That will give us time to see the what's going on with in logs. Okay, so even if we see something in red, we can we still have some time to figure it out, make it work, and once we start seeing everything in red in green, I mean, so everything started working, we can go to the low impact mode or even to the closed mode if we can. I know some deployments that people, 2 years after the deployment, they are still in the monitor mode because everything works and they don't want to change the mode at all. For a manager, it's that manager doesn't know that. It's okay for them. Right. Okay. So the question about this radius, server debt criteria, and stuff like that, I'm not using those. But generally, if we are talking about the configuration for a switch, there is a one good reference for that. This is called Cisco Universal Switch Config for .1x. Okay, Cisco ISE, I think, Universal Switch Config. I'm not sure if that's the latest. Okay, let me check. Okay, let me give you a nice ISE resource. I have even the bookmark here. Okay, put that in the chat for you guys. This is the ISE and NAC community resources. There are a lot of useful information, especially like this documentation. If you're looking for documentation for a specific version of ISE or release notes, compatibility, admin guide, install guide, migration, CLI, everything here. Some training, licensing, you looking in that and you get everything. Switch, how it's the switch configuration is. That's the one page with all the links, the documentation and documents. Check that out. Okay, let me open that and see. Oh, I even have it. Okay, January 17. It should be something a bit more. Oh, okay, yeah. So that's a good document, right? You know, taking you for the step by step for the configuration of the switch. We're gonna be going through this. At least that is the plan, to go through the switch configuration one by one, because not everything in that document is important. But you should have information about what you are asking about here. By the way, if we get back for a second to not here to this ISE one page with links, what I need to tell you is this compatibility. When you click the compatibility, you go to the network component compatibility with ISE, particular version of ISE. For example, you have that validated Cisco access switches. And believe me or not, but this is very important. If you have a switch, for example, you have 2960 LAN base, okay? You need to take a look at the validated and minimum OS. That's not a big deal. The validated OS is what is important for you, because that was the validated by Cisco, this version, and they claim that all those features work fine. They are available here, okay, and working fine. So if something doesn't work for you and you think that it might be the switch issue, you can open a case and say that this is based on a validated operating system. But sometimes this validated OS it's already too old, and you need to use the newer one. Then you obviously need to do that, but people from TAC, they may say that you are not using the validated uh, version. What I learned is this: I treat the validated OS as a minimum OS version that I should use on that specific platform to make ISE work, okay, with it. And that's very important because there are many different uh, softwares and different ways that the software may not work, even for the same platform. Oh, you got that. Oh, nice finding. Thanks for that. I will learn that maybe something from it as well. Okay. Okay. So I think that's gonna be it for today. And for next week, will the plan is to go through the Mac authentication bypass, then machine authentication, user authentication, and how we can make that work together. Okay, there are two mechanisms: MAR, machine access restriction, or IP chaining. But in order to use IP chaining, we need to have another supplicant. We need to have Cisco supplicant, which is the AnyConnect NAM. So we will install NAM. We will migrate from the native supplicant to the AnyConnect NAM. Use it, and then I will talk about guest access and maybe something more if time allows us. Maybe we'll start talking about the posture. Right, we'll see. Okay, so guest and AnyConnect NAM those are two big topics for the next week. Okay, guys, so yeah, that's it. Let's call it a day. I hope it was informative for you today. You learned something new. This is a big topic, hopefully for you guys that already know ISE, it was still some, informative. Right. Thank you again for being with me today, and yeah, see you next week. Cheers. Have a nice rest of the weekend.